Proud that ICIST conference is taking place for 26th time. This conference attracts scientific participants not only from Lithuania, but also from the world. During the global pandemic, I'm glad that this event was adopted, and we will not lose an opportunity to hear scientific reports on important topics. So get involved here and discover inspiration for future scientific decisions. Thank you. And now I would like to invite our Vice Rector on Research and Innovations, Professor Leonas Balaševičius. Welcome.
Good morning, ladies and gentlemen. Thank you for keeping the distance between each other when you're sitting here. So I will allow myself to take off the mask from my face that you see me. First of all, I would like to bring my sincere gratitude to the staff of the university for their contribution to our university, and also a warm welcome to participants from research institutions, from universities, from industry, and from business. So I'm very proud that you are participating here, also in the Santaca Valley. Also, warm welcome for those who are participating in the conference online. If you allow a little bit for me to bring some short presentation about the Kaunas University of Technology. So I'm going just to share my screen. I hope you see now it. First of all, I would like to start from one logo you see here in my presentation. It's ECIU University. As you know, last year the European Commission started the initiative of European Universities Network. So Kaunas University of Technology participating in one of these networks together with partners from European Consortium of Innovative Universities in this case. Why it's important, I think, also for participants of this conference, it's due that the main idea of this ECIU University network is to provide at the end of 2023 the challenge-based learning master in this case. One of the topics I saw in your conference, it's related with e-learning, with learning of the languages. So I think it could be discussions between the participants of the conference, also regarding how the researchers could go with their research topics, also to provide opportunities, even in this COVID-19 pandemic situation, when the online learning and or online teaching becoming so more and more important. I would like to start just from some geography facts. Lithuania is in the south of the North Europe. So you could see here, we're belonging to the North Europe, but we are in the south of the North Europe. Regarding the Kaunas, Kaunas is in the center of Lithuania. Especially I would like to tell this for those who are participating online to this conference. So I would like kindly to invite you in 2022 to the university, because there will be a lot of the events at the university. It will be 100-year anniversary of the university. At the same time, Kaunas will be European cultural capital. So definitely you will see not only great scientific events, but also cultural events at the city here in Lithuania. Next, when we're talking about the Kaunas, we would like to bring an attention to the Kaunas innovation ecosystem. It's also very important for us, as for university, but also maybe for companies, maybe for other researchers, that there is a very huge community of students, of researchers, who are creating the value for society in this case. And maybe the main topics when we are looking to the future are Industry 4.0, digital transformation, health technologies, food, new materials, energy, creative cultural industries, and of course, innovation and entrepreneurship. So these are key topics here which are developed at the Kaunas innovation ecosystem. The key sectors of the industry, what we have here around Kaunas, are related with medtech, ICT, MRO, and automotive sectors. Also, you see some big companies, international companies, who are participating here. Now, regarding the university. Currently, at the university, we have 9 faculties and 8 research institutes. Also, we have 4 campuses in 3 cities. So 2 campuses in Kaunas, 1 campus in north of Lithuania in Panevėžys, and 1 campus in Vilnius. Kaunas University of Technology is one of the biggest owner of the International School of Management in Vilnius. Also, I would like to put your attention to our publishing house Technologia, who is printing at least 5 journals, which are included in the Clarivate Analytic Web of Science database. They are open access journals, so I would like to invite the international researchers to publish their research results in these journals. Regarding the strategy of the university, I'm not going to read it, but I could clarify only that this year we're designing the new strategy for upcoming period for 2021-2025. So definitely, if you are going to participate next year in this conference, you will see the new university strategy for next upcoming 5 years. Some facts about the university. It's about 8,500 students. About 11% of these students are international students. About 900 of academic staff we have, which provide also as teaching, as doing research at the university. Also, there are a number of programs in English for bachelor students, for master students, and also PhD students. Regarding the main research areas of the university, till now, till 2020, they very good fit to the Lithuanian smart strategy specialization in this case. So the main topics were 5 topics, and we are very succeeding in doing research and, of course, attracting the competitive funding in these topics. Regarding the PhD studies, currently at the university we're providing the PhD studies in 19 fields of science. Of course, in all possible fields of science at the technological sciences, but also there are fields in the social sciences and humanities. What's important, about half of these PhD studies are done with foreign partners. So we are also offering for our PhD students the double degree or double diploma. Recently, we are finishing the agreement with Bologna University from Italy, and the double degree fields of science will be expanded. Next, maybe a very important feature, what we are preparing for our new generation of researchers. So I'm proud to say that we have, if we take a look from the point of view of the university, it's about 50% of females are seeking their PhD degree. Also about the 50% of males are seeking their PhD degrees. Of course, if we are looking to some specific field of science, in the technological sciences, of course, there are more males, but at the same time, in social sciences are more females. But equality in this case is kept at the university. Next, what university is proud, it's the success participating in the H2020 program in this case. We're absolute leaders in Lithuania, not only among the universities, but also among all participation of Lithuanian industry, companies, small, medium enterprises, and higher education institutions. You see the facts from the 2014-2019. So the total university in this period had 31 H2020 project. Currently, at the end of this year, we are implementing 42 Horizon projects. And recently we got a message that another 7 H2020 projects are won, and we are starting them in 2021. Of course, regarding when we have research, successful participation in the Horizon 2020 projects, it's very important to bring some entrepreneurship skills to our students, to our researchers, but also collaborate with the industry and business. University has its own technology transfer office. It's named National Innovation and Entrepreneurship Center, which acts as one gateway between the industry and academia. What's important for us? So it's R&D revenue from the industry companies. Each year it increases. That means the university researchers doing the research in the topics which are important for the industry and, of course, for the society. Also, especially for the attenders from the industry companies, I would like to put an attention that you have very good opportunity in case you need to do some experiments, some research at the university, or use some specific equipment. You could check this in the website apsis.ktu.edu in this case. When we're doing or creating new knowledge, it's very important to protect it and, of course, to license that knowledge. And in this case, you see the graphics, how changing the number of patents, which are owned by researchers of the university. Next one, we started to promote the entrepreneurship skills to the students, and starting from 2012, we have more than 90 startup companies established by the students of Kaunas University of Technology. And of course, you maybe were interested that about half of all these startup companies are in the IT field. Next one, I would like to invite even you or the conference participants to visit virtually this year the biggest international innovation fair. You see the facts from the last year event. This year event just started 2 weeks ago. It was organized online using the virtual platform. So during the break, I definitely invite you to visit technorama.ktu.edu and to see what innovations are created by our students, our young researchers, and to see virtually how we're presenting their innovations. Of course, the exhibition of that fair is finished. We know the winners of this exhibition, but that exhibition will be open at least 6 months in advance. So, what I would like to wish you, first of all, a productive conference, good networking. Next may be challenge the well-known and explore the unknown. So, good luck in the conference, and I hope next year there will be big audience here in the 2 halls of the Santaca Valley. Thank you.
So, dear colleagues, let me introduce myself. My name is Audrius Lopata, and I am the chair of the program committee. And first of all, I am very glad that this event was organized despite the challenges of COVID-19, and we are currently attending its opening ceremony because I have personal experience that at least 2 international scientific events I have planned to attend in this year has been cancelled or postponed. So I would like to thank all those who contributed to the organization of these events. For first to the authors, reviewers, keynote speakers, chairs of special sections, faculty and university administration, including the dean and vice rector who attending the ceremony, and the members of program and organizing committees, technical staff, and all others who contributed to the conference, but I did not mention. Of course, it's a pity that the absolute majority of foreign guests, foreign colleagues, did not have the opportunity to come to Lithuania, Kaunas, but I hope that this will not only prevent you from gaining the new knowledge, getting to know new colleagues, gaining new experience, but also having a great time here in this conference. So welcome to ICIST 2020 conference. Thank you very much. And now we should connect with Professor Ajit Abraham. Okay, so let's wait for several minutes.
Night.
Great, great. Thank you. So you can start.
So we can start right away?
Yes.
Okay, so let me just put it slide. Yes. So good morning, good afternoon, good evening to all of you, and I would like to congratulate the organizers of ICIST 2020 for putting up this wonderful conference. Actually, I had been to this event a few years ago, and it was really a wonderful event. I still remember the social program we had with some live cooking and things like that. It is still in my mind, and I feel sad that we missed the real meeting this year. But unfortunately, the COVID situation uh, prevents all of us to be together, and I hope that next year we will have a better opportunity to see in person and or meet in some other event. So I would like to especially give a more generic talk because I know that all of you come from different background, and myself I am from an AI background, so I'm going to touch various topics during the next 1 hour or so. So today's topic is Industry 4.0 and Society 5, the role of AI and data sciences. I'm sure all of you are very familiar with Industry 4 because it has been there and we are enjoying the fruit of Industry 4 during the last several years. The fourth industrial revolution. Society 5 is actually a similar framework proposed by the Japanese society. As you might know, in Japan, a lot of technological advances, automation, uh, and basically, like AI, data sciences, all these things, they were immensely, being used during the last several years. But today they are more worried about how these technologies could be useful to the society. So more than the technological revolution in the Japanese version, the Society 5.0, they're talking more about how these technologies could be, useful to the community at large, whether it is healthcare, whether it is education, whether it is, maintaining law and order, etc., etc. How can you make use of these technologies so that we can uh, make the society better or the community better or enjoy a better lifestyle. So it is not only manufacturing, not only automation. And when we talk about Industry 4, but the Japanese version, it is more towards human life, happiness, comfort, uh, well-being, better healthcare, etc., etc. So I will give a quick introduction to Industry 4, followed by Society 5, data sciences, intelligent computing, and some of our works towards this direction during the last several years, followed by some conclusions. Uh, so for those who are new to Industry 4.0 or the fourth industrial revolution, so we are talking about the fourth revolution. The first one started in the end of 18th century, where we tried to use uh, water and steam power for very simple sort of moving wheels or very basic automation. And the second revolution started in the beginning of 20th century, where we tried to use electric power. We also tried to build roads, rails, connecting different cities, villages. We started seeing what is called as the real revolution in a big scale. And in the beginning of the 1970s, we had terrific technological advances in the electronics field, integrated circuits, small scale computers, birth of AI, so-called information technology, embedded systems. So all these things, took automation and manufacturing to a new level, and it is called as a third industrial revolution. And finally, what we are seeing today is the fourth industrial revolution, where we are seeing a marriage of several systems together in a very nice way. We see cyber physical systems, we see Internet of Things, we see robotics, advanced automation, various other technological frameworks, including information security, cloud computing, and variety of other frameworks all together. Then AI and data sciences, which is more like a fabric. So we have all these various technological, frameworks, and then AI and data sciences is being used as more like a fabric for processing this complex amount of data and getting meaningful information. So we are actually enjoying the fruit of fourth industrial revolution. If some of you are not familiar with this term, actually, I would say that we are all enjoying the fruit currently. Society 5.5, they try to categorize this revolution in basically 5 stages. And if you look at the stages, some of them are very common, very similar, and they overlap with the Industry 4.0. So basically, they go back to the birth of human beings, where it's just more like hunting society. Then in the 13,000 BC, we had more like a agrarian society, where we tried to use irrigation techniques for mass scale agriculture. And 18th century, which is very similar to Industry 4.0, the first revolution, the steam locomotives, and further the use of electric power, etc., etc. And then the fourth stage, that is the late half of the 20th century, the mid, I would say the early 70s. It is very similar to Industry 4.0, the third stage, the IT revolution and embedded systems, electronics, etc., etc., information society. And then finally, well, they call it as a super smart society, or Society 5.0, from the 21st century. So you can see there are sort of very, a lot of overlaps between Industry 4.0 and Society 5.5. Sorry, 5.0, but basically the overall theme is slightly different. Industry 4.0 is purely technology oriented, but 5.0 is aimed towards society. So I'm not going much into details about Industry 4.0 because all of you are very, very, very familiar, I would assume. So I just want to give a quick introduction to Society 5, how these technologies, could be useful and how they could be benefited in different aspects in the society. So right now, like we have several applications, but knowledge information are not shared, and actually cross-sector value is difficult to create. So basically, humans are playing a big role in linking different things. But it is believed that when you have Internet of Things that will connect people and various databases, then all sort of knowledge and information would be shared, and this could actually create new values. We have a lot of issues. For example, aging society. We have our villages or towns which are sort of scattered around, and integrating them into the system is always a challenge. But under Society 5, it is believed that we will be able to overcome such social issues. We will be able to make use of automation and associated things for taking care of aging society and supporting their needs. we have an overflow of information right now. We have various devices, sensors, instruments, and it is not easy to analyze all this information and make intelligent decisions. So, but with Society 5, Industry 4.0, I would say together, we'll be able to process this massive amount of information and uh, and make intelligent decisions. It is believed that robotics or assisted, mechanisms could minimize human labor, especially tedious tasks, repetitive tasks. So, for example, we are seeing automated cars using robotics in various ways, in from hospitals to shop floors to restaurants. Today, we can see such automation. It is becoming very common. So we're going to see such things more often. So if you look at the current information society or Society 5, the fourth stage, which I would say we are almost passing now, we would see like the data sharing is not it's not horizontal, it's more vertical. For example, someone searches for some location navigation and then he gets information and the person has to analyze it and then again go back to 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 the knowledge base to get more information, etc. And finally, the human plays a big role in going back and forth. But in the future, or I would say in currently, what we are expecting is we have big data technologies, artificial intelligence, data sciences all together would act like a fabric. So we have all this various sensor information, IoT, cyber physical systems, various things which are monitoring or controlling various applications. Data is read from them, and we will be able to make more intelligent decisions without much human intervention. So basically, human will play a slighter role in Society 5. So basically, AI and data sciences will take over much of human role or human repeated tedious jobs. So basically that is towards that. So basically it is believed that we will be able to extend a healthy life expectancy, social costs will be lowered, stable supply of energy, greenhouse gas emissions will be reduced, improving productivity of foodstuffs, reducing waste, a promotion of sustainable industrialization, a lot of other things which could help the society at a big scale. So overall, I would say Society 5 is aimed towards comfort, vitality, and high quality lifestyles. So basically, we will not know much about what is going on uh, with various application layers, but the system will automatically will decide what is the best possible way to have those metrics. So if you look at Internet of Things, it has a massive potential. Basically, it has now become like a fabric in several applications. It could reduce costs. It could reduce uh, various other efforts. It could improve performance, create innovative services. It could generate new revenue streams, innovation. So basically, you can imagine, like sky is the limit for for IoT if you really use the capability and the potential. But if you look at a bit deeper, like I talked about various things, but if you look at a bit deeper, if you look at the the volume of data, the massive sheer massive volume of data coming from these various sensors, instruments, monitoring devices, streams. So basically, we need to deal with volume, we need to deal with velocity, we need to deal with variety, and we also need to deal with shared, and I guess these things is very difficult for us to give us proper answer. So basically, we need to deal with a variety of data. So basically, we need to deal with sometimes graph data. Sometimes we need to deal with multimedia data. Sometimes we need to deal with text data. Sometimes we need to deal with stream data, variety of data, and coming in what is called as streams, velocity, and also high volume. We're talking about gigabytes, petabytes, exabytes of data. So basically, massive amount of data. And thanks to big data technology, actually, there are a lot of interesting frameworks already available there. For example, like MapReduce, Hadoop. Then there are several off-the-shelf commercial and non-commercial packages from MATLAB, R, SPSS, SAS, etc. Then if you want to have deep insights, for example, there are various unsupervised learning schemes. There are various analytical methods. For example, we can use even analyze graphs, complex graphs. We can use various machine learning schemes for uh, understanding data at a very big scale. There are several visualization schemes. Sometimes it is easy to visualize than to analyze massive volume of data. So there are various ways to to get a deep insight. But again, if you want to have a real deep insight, then we need to really fine tune some of these algorithms or some of these AI data science methodologies so that we can find the optimal, so-called the best knowledge out of it. So then we need to really develop some nice methodologies. So in AI, what we call as like finding patterns. So if you can find patterns from data which others cannot find, then we can say that we have developed a successful application. For example, if you can find information which your competitor cannot find, then basically you can do well in your business. Or even a university, if you can find your students, what your students are looking for in university, which other universities cannot do, then basically we can create value added courses, value added programs, etc. So finding those patterns is the key. And there are several types of patterns. For example, if you look at iris, if you look at speech, if you look at fingerprints, if you look at face, signature, the way you move your hands, the gait movements, there are several types of patterns. So finding the right patterns is often a challenge. So if you look at data like this, like number plates from different states in US. Basically, it is very simple. Basically, if you do some very simple image segmentation, you can actually extract those letters, states. You can easily use, very simple uh, pattern recognition methods, and then identify the number plates. So typically, what you do in AI data science is, what we do is we create a model, we build a model using training data. We might have to do some pre-processing, we might have to do some feature extraction, feature conditioning, making sure of the quality of data, getting the right features. Then we build the model, then we save that model, then we do the testing phase. And if you see that both these errors are sort of like comparative, then we can say that we build a nice model, or the model seems to work very well. On the other hand, if the testing error or training error has a lot of differences, then we have to come back and think. We need to probably tune certain aspects of the model, or choose another model, or fine tune the model, etc., etc. So there could be several issues. So we need to carefully look at the training and testing error, especially when we build AI data science models. It's also important to choose the right set of features. We need to understand certain things like invariant features, and we might have to deal with noisy features, missing features. Sometimes we have to deal with curse of dimensionality. For example, if you have thousands of features, then we might have issues with a bigger model. Sometimes certain models may not be practical, so we might have to reduce the feature size so that we can handle that using some compact model, etc. So, in a nutshell, we can categorize various machine learning schemes into several categories. For example, one is function approximation, where we try to use various regression, classification, pattern recognition schemes. So you can think about neural networks, support vector machines, decision trees, various supervised machine learning methods. The clustering is another interesting field, where we try to group similar looking objects as close as possible, and objects that are different as far as possible. So basically, we try to keep the intra-cluster difference as close as possible, and the inter-cluster difference as far as possible. So basically, it is an optimization problem. So usually, we start with random senders, and then the number of senders, and we use some optimization method, and then we try to group these objects as close as possible. Another area is the field of approximate reasoning, where we tend to deal with imprecision and uncertainty, vagueness, etc., etc. So certain things, if we go for precision, it might not work in practice, because your model needs a lot of computation, a lot of processing, and probably it might not be useful in real life. And many a times we need to deal with imprecise, vague information, and as long as we can find a solution, that is perfect. Of course, we are happy if we can find precise or exact solutions, but many a times in real world, if you look for exact, precise solutions, it might not work in practice. So many a times we need to use this imprecise, vague information, and then try to get the best possible solution. So approximate reasoning deals with those type of challenges: fuzzy logic, rough sets, various other methods. And probabilistic reasoning on all these things deals with such modeling aspect. Optimization is another major area, where we try to find the best solutions for a particular problem. For example, finding the best shape of an aircraft wing, or how should you load an airplane, a cargo plane. For example, you have several metric tons of load, and what is the best way to load the cargo? You have different types of boxes, different types of materials, and how you should optimize so that the space is utilized, and also the loading is done in the in the fastest possible way, and also unloading. When the flight reaches, you have to offload too. So basically, you can see different types of problems. The traveling salesman problem, where you can imagine a salesman traveling to different cities, and he or she should not visit the city more than once, and he should have the shortest path. So basically, life is full of uh, optimization problems. You could see, like the whole process in different ways. So basically, in a nutshell, you can categorize AI, or I would say intelligent computing, into a few different categories. Approximate reasoning, where we have various probabilistic models, fuzzy logic, rough set, and various other reasoning methods. Then approximate reasoning, we have neural networks, support to machine, decision trees, various other machine learning, supervised learning schemes. Randomized search, we are dealing with optimization, where we have lot of global optimization methods. We could start with meta heuristics, simulated annealing, taboo search, to population-based approaches like evolutionary algorithms, swarm intelligence, various other novel meta heuristics, which you're seeing every day, almost every day. Okay. So just to give you a quick introduction to some of these key areas, for those who are not familiar, I just want to give a quick introduction, because I'll be going a bit depth about like various combinations of these methods. So just to give a quick introduction, so evolutionary algorithms, born in the early 60s, so basically mimicking Darwin's theory of natural selection, where the idea is fitter the parents are, they will get opportunity to find food and produce offsprings. So the idea is the offsprings are always better than the parents. Natural selection. The fitter parents, they produce more better offsprings. And even though it looks very, it is very simple to explain, but the algorithm itself, there are several categories. For example, evolution strategies, evolutionary programming, genetic algorithm, and genetic programming. So basically, it depends upon how we represent the problem. For example, if you use bit strings, we could use genetic algorithm. If we use trees, we could use genetic programming. If you use real number strings, we would use evolution strategies. Depending upon the operators, crossover, mutation operators. For example, some of these algorithms doesn't use crossover, some uses only mutation, and some uses strategies for evolving the population. So basically, depending upon these, there are 4 different categories, and we have seen a lot of usage of these symbol meta heuristics during the last several years. A lot of interesting practical applications. Artificial neural networks, a major tool in function approximation. Initial ideas came in the 50s, and over time, with this technology is very, very matured. We are trying to mimic something similar to a human brain, where we learn from examples. We see examples, and then we try to learn and generalize. For example, if you look at the sky, we can tell that whether it will rain, or if you feel the wind, and if you look at the sky, we can easily tell how much time it needs to rain, right? So we need some very simple information, and rest of the things are from our experience. So basically, probably when we were children, when our parents taught this, or through our friends, through media, through learned knowledge, okay, personal experience. So we developed all this, like sort of meta knowledge. So artificial neural network is one of the, like the tool set within artificial intelligence, where we try to deal with function approximation, pattern recognition. So like I mentioned, it is like a 70-year-old technology. So basically, the foundations until now, a lot of development. So it is impossible to summarize, probably in a day. So basically, you need like several days to at least, like illustrate what are the different things available. So basically, we try to, formulate a structure, and then we try to use some mathematical algorithms to optimize the weights, those connections. So we try to mimic a brain. We try to arrange layers of neurons, and then we try to interconnect them, and then we try to optimize or find the best connections of these weights so that we can get the required solutions, or we make the network learn. Okay? So basically, there are several learning methods, several neural networks. There are probably more than 100 different types of such schemes. And one of the popular schemes nowadays is the field of deep learning, where we try to use many layers for this learning process and making this learning process more efficient. So I will quickly get into that very soon. But so basically, neural network, what you do is we try to generate some random weights initially, and then we try to use some sort of mathematical methods, for example, like backpropagation, a conjugate gradient, or Leeuwenberg-Marquardt. So there are several learning methods, gradient based to higher order information. So basically, depending upon the application, we try to use different learning methods. So basically, what it does is, for example, if you want to categorize two classes, for example, like green and yellow, you see two classes, and then basically we start with random, and then slowly as the learning process goes on, you could see that you could see a nice boundary between the two classes. So this process is called learning. So we could use different learning methods, and depending upon the number of neurons, for example, if you use 3 neurons, 6 neurons, 20 neurons, you could see the complexity of the decision boundaries. So when you tend to use more hidden neurons, you could see that you are able to construct a more complicated decision boundary. So it doesn't mean that we should always use a higher number of hidden neurons. So technically speaking, for a given architecture, for example, given number of inputs and given number of outputs, and for a fully connected neural networks, finding the best numbers of hidden neurons and the best connections, or the optimal values of this connection weight, is found to be NP hard problems. So basically, we are trying to deal with I would say sort of approximate solutions using various heuristics. So technically speaking, all these learning methods, we are trying to play around the North-Freeland's theorem, which says that there is no single learning method that could work well for all class of problems. So typically, we can also translate that into a neural network framework, where if you use a learning method, we are not able to find the best possible learning method that could be useful for all class of applications or all class of data. So one example could change the performance of a neural network. In the case of deep learning, we are trying to look at it in a different perspective. We are trying to mimic in a much more closer way the way we humans process information. For example, we tend to extract what you call as high level features. For example, I can recognize some person just by listening to his voice, or just by seeing the way he walks, or just by seeing the way he smiles, or just by seeing one angle. I don't have to see even his face, or just by seeing his the hair at his back. So basically, we humans, we tend to learn high level features, and this is useful for learning complex patterns. So deep learning is all about extracting high level features, and you're trying to extract the information and then pass the information to layer after layer, and then finally you are able to have a network that could learn the problem more efficiently, which a traditional neural network might find difficult because of the massive volume of data as well as the massive number of inputs. For example, if you have speech, if you have images, multimedia. So basically, you tend to have a lot of input features. So basically, you need to compact. You have to deal with curse of dimensionality. So you need to have sort of feature extraction. So deep learning tends to be the best option for that. So for example, if you want to categorize handwritten digits 0 to 9, so basically you could see some sort of features. For example, there are zeros, some circles, and you could see the circles, for example, in 2, in 6, in 8, and zeros. For example, in 8 there are 2 zeros. For in 9 you have 0 on top, and 6 you have 0 on the right and bottom. So basically, you have we try to understand these digits based on these high level features. So we are trying to mimic this in a very artificial way. And these, in the case of deep learning, these hidden neurons will tend to learn these high level features. For example, there are neurons which could learn some horizontal lines, there are neurons which could learn vertical lines, and there are neurons which could learn small circles, and there are neurons that could learn various other features. And finally, these features are passed from layer to layer in a typical fashion, just like we train conventional neural network, and finally we get the output. So basically, we call it as a autoencoder. So each layer is trained to be an autoencoder. So basically, we are trying to extract high-level features from the previous layer, and then it passing on to the next layer, and until we get the required solution. So there are various other deep learning methods as well. So if you look at the literature, you can find a variety of other methods. Another practical approach to optimize neural network is using evolutionary learning methods. Again, it dates back to the late or the early 90s. Basically, several researchers started developing different frameworks for optimizing various aspects of a neural network. For example, architecture, for example, the number of neurons, the parameters of the learning method. Okay, so various other methods. So imagine if you look at the screen, you could see one on the left side, one on the right side. And imagine if you can have a neural network which is smaller in size and which is more efficient than the traditional, like fully connected architecture, which is bigger. So basically, we are looking towards that direction. So we want a network which is smaller, compact, and also better performance. So if you look at a feed-forward network, when you see on the right side, you can translate that into a matrix form on the left side. And if you just concatenate all these values in the form of a string, you have a chromosome. So basically, you have a neural network represented in the form of a chromosome. So it's a feed-forward network. That means that the whole upper half is 0 and the lower half is only having some real values. So the lower half is having the weights, and you have a chromosome representing the weights, and then now you have a coded neural network. And then you can use simple crossover, what you're seeing on the screen. You can exchange some fragments of the parents, and then you get a new child or a new neural network. Or you can do mutation. You can just use some operator, like for example, like injecting some noise to the current values, and then you get a totally new neural network. So using crossover mutation, you can actually search the variety of options or search space more efficiently, and such schemes are being used very much and found successful in several applications. So one of the areas where we touched is to use what we call as the flexible neural trees, where we try to make the process more automated. So basically, it does feature selection, and it also designs architecture. And basically we try to use what is called as a version of genetic programming, which is also called as the probabilistic incremental program evolution, or PIPE. This is actually a very, very established method, the probabilistic incremental program evolution. I think it was first used in the mid 90s, and it has been used widely for for evolving trees or tree-like structures. So basically, neural network is more like a tree, and then we try to use this method so that we can easily represent. So, for example, the entire knowledge is encoded in a probabilistic prototype tree, which actually keeps track of the growth of individual nodes. And depending upon the contribution, you have some probabilistic values, and these values determine the growth of individual nodes. For example, a node with high probability, which means that this node is contributing a lot towards final results. So basically, the more importance is given to this node, so the growth factor will be a lot more for this node. And by using operators, for example, like +3, +2, basically you can add as many number of leaves. For example, +3 means it can take 3 instructions, +2 means it can take 2 instructions. So the node can grow just by changing the instruction set. So you can imagine just by presenting what is called as instruction set, +2, +3, +4, +5, and your input variables, x1, x2, x3, and basically algorithm can easily grow what is called as trees or neural trees. So what you see on the screen is an example of a neural network, or what you call as a neural tree. So you have +2, +3, +3 mean can take 3 instructions, +2 mean can take 2 instructions. If you look at on top, the output layer, it is actually +6, which means that it can take six inputs or 6 instructions at one time. So you can imagine, using symbol operators, we can construct a massive volume of trees, and the search process, gets more efficient, and you can get, better decisions. So I'll go straight into some illustrations. So basically, we try to use this for gas furnace time series we see on the screen. So the bottom 2 rows, the first case and second case. The first case is without time lags, and second case is with time lags. So the gas furnace time series has 2 input, 1 output. So basically, we try to inject some time lags. So for each input, we try to inject 12 time lags. So total, we had 24 plus 2, 26 inputs with time lags. And you can imagine the network automatically selected 7 inputs. And then, the mean squarer you see on the extreme right, and the last 2 rows, you could see that with time lags, the performance seems to be a lot better. So that is the basic idea. With time lags always help to improve the performance. The Mackey-Glass time series, another popular benchmark. You could again see the bottom 2 rows, case 1 and case 2. So case 2 is with time lags. So you could see that with time lags, the result seems to be a lot better. Intrusion detection, another popular benchmark dataset, 41 variables. You could see that in many cases, you only need like 9 to 10 variables. So rest of the variables are not required, and you could see the performance is also pretty much good. This is again some benchmarks. Colon cancer, flexible trees. You could see that the error is like this, 97.09. And leukemia, another popular benchmark dataset, 99.6. So it looks very nice, actually. The construction, development, implementation, etc., is pretty easy and pretty neat. But we came into a few issues like complexity. For example, we have big networks that are very accurate, and sometimes we have small, very compact network that is not very accurate. So many a times we need to deal with the complexity and accuracy. And for neural networks, if you have a diversity in the number of activation functions, it tends to generalize better. So we tend to have a multi-objective optimization formulation for getting what is called as a Pareto optimal solution front. So in that we can have a trade-off between various objectives. So we try to plot the various solutions in the form of a Pareto front, and then we can make the best trade-off. So we try to use multi-objective flexible trees, which is one of our latest works. And we have also done several applications. So these are some benchmark data sets. So you have, these are some very popular benchmark data sets. You could see the accuracy for training and test. And this is the wine data set. It has like 30 plus features, and you need only 5 features. So with 5 features, you could also get a very reasonable accuracy. And this is for regression problems. The other one is for classification. This is for regression. You have 5 data sets, training and test, mean of 30 models. You could see that the performance is very reasonable, even when compared with other supervised learning schemes. Coming to the last part of the lecture is about approximate reasoning. So fuzzy logic rooted from multivariate logic. I think it came somewhere close to Lithuania. Professor Jan Lukasiewicz. I think currently I think it's in Ukraine, this region, and Professor Sade coined fuzzy logic, the principles of fuzzy logic in the mid-60s, fuzzy sets, fuzzy if-then rules. He formulated a nice way to deal with implicit uncertainty. For example, if you say if someone is old, like 80 years old, in crisp logic, we would say like 0, 1, 80 is 1, 79.99 becomes 0 suddenly. But fuzzy sets, fuzzy logic use the concept of membership function. We can say someone who is 75, he has a degree of association of 0.9, or we can say is 90% old. And someone who's 80 is 100% old. And using if-then rules, we can easily translate various kinds of knowledge. So, and using the concept of linguistic variables, we can actually process imprecision and uncertainty in a very, very nice way. And for those who are familiar with fuzzy modeling, many a times it's a challenge. You need to decide the relevant input-output variables. You need to decide the relevant inference method. You need to deal with the number of linguistic terms with each input-output variable, or I would say the number of fuzzy sets you should associate with each input-output variable. Then if-then rules. Then if you go a little bit deep, you need to decide whether you should use triangular, trapezoidal, Gaussian membership function. If you have partial knowledge, if you have expert knowledge, how we can incorporate them into the system. Finally, you have to fine-tune the various membership function parameters using various other machine learning or optimization methods. So basically, you could see that it's a big challenge to design a fuzzy expert system that works in practice. And one way we overcome the traditional challenges using neurofuzzy models. So in a neurofuzzy model, we try to lay out the fuzzy expert system in the form of a neural network-like structure, and then we try to use supervised learning schemes and simple mathematical optimization procedures to learn various parameters. For example, tuning the membership function parameters, and also the output membership function parameters, etc., etc. So we tend to use various sort of neural network type learning methods. So that's why it is called as a neuro-fuzzy method. And just to give you a flavor of what neuro-fuzzy systems could do, so basically this is actually a very old slide. Just to give you, this is actually for a Mackey glass time series. So if you look at the neural network on top, and if you look at in the bottom on the y-axis, this is actually adaptive neuro-fuzzy inference system. This is a neuro-fuzzy system developed by Professor Zhang in the early 90s. So just to give you a comparison between two, so a neuro-fuzzy system is, it produces an error as almost 1/3. So neural network produces 0.0047, but neuro-fuzzy system has only 0.0017. And there are also several other neuro-fuzzy methods you see on the screen, but comparatively, neuro-fuzzy, the neuro-fuzzy method, which is actually a Takagi Sugeno neuro-fuzzy system, which seems to work the best. So what I want to say is a neuro-fuzzy system seems to work a lot better than traditional neural networks for many practical applications. Another way to optimize fuzzy systems is using evolutionary approach. You use some optimization methods to tune the membership function parameters, to find the best combination of rules, tuning various other parameters in the expert system, etc. So one way is to use Michigan approach, where we have each chromosome represents a rule. So we have a population of rules, and then we try to use the mutation crossover so that we get we evolve and we finally end up with a nice set of rules. Pittsburgh approach, we have each chromosome is actually rule based. So we have a population of rule bases, and then you can imagine crossover means you exchange several rules with another parent, and then you get a totally different rule base. And finally, towards the end, we get a population of rule bases. So typically, a Pittsburgh approach is used for offline approaches because it is really computationally very intensive. Iterative rule learning is another method where we start with a small rule base, and then we try to add new rules depending upon the need. So depending upon the contributions, we try to add new rules, and also we penalize those rules which are not contributing to the output. So just to give you a flavor what neuro-fuzzy systems could do. So on the screen, you see that on top, you have a neuro-fuzzy system, which this is actually for the Mackey glass time series. So basically, you could see that the error is 0.008. And just below is a neuro-fuzzy system, a Takagi Sugeno neuro-fuzzy system, which is 0.0017. So the evolutionary fuzzy system is almost, the error is almost half when compared to a neuro-fuzzy system. And if you compare with the neural network, you could see that error is like almost 1/6. So evolutionary neuro-fuzzy system seems to work a lot better than a neuro-fuzzy system. Just to give you a flavor, what these different models could do in real life. So finally, we also try to import the same idea which we used for neural network for fuzzy expert systems as well, especially in the case of expert systems dealing with hundreds of thousands of variables. We have the problem of curse of dimensionality. We cannot use a traditional fuzzy modeling approach, because even if you have a small number of linguistic values for each variable, then you have problem of curse of dimensionality. For example, if you have 2 membership function per input variable, and if you have 100 input variable, you have 2 raised to 100 number of rules. Very unpractical. So basically what we did is we tried to break down these rules into rule bases into compartments, what we call as in a hierarchical fashion. For example, if you have 4 variables, you have a structure A, structure B, structure C, structure D. You have one of these 4 structures. Okay, and imagine if you have 100 variables. So you could have, it's beyond our imagination. So it is more like an NP-hard, NP-complete problem. And basically we try to use a very similar approach we use for neural trees using instruction sets. For example, you see on the right side, you have B1. So basically it translates to something like here, B. So basically you have +3 means it can take 3 instructions, +2 it can take 2 instructions, and which translates into, on the left side, it's an hierarchical fuzzy system. So basically you have rule bases or rules in these blocks, and then you interconnect them. So basically we just need to propose the instruction set and the number of input variables, and the algorithm automatically builds what we call as those structures. So this is for the Mackey glass time series. You could see that some comparisons with other methods. This is for IRIS data, 4 features. So you could see that sometimes we need only 3 features, and you could see that it has almost 100% accuracy. Okay. So this is for the wine data. So you need only 4 features many times. Okay, even 5 features, you get 100% accuracy. Again, the problem we came into this framework is we have a small fuzzy system which is very compact but not very accurate, or we have a big expert system which is very accurate. So we have the problem of trading off between complexity and accuracy. So something similar to what I mentioned earlier. So we have a very complex but accurate model, or we have very simple but inaccurate models. We have a trade-off. So we try to use, again, multi-objective genetic programming in this case. And these are some control systems, just to give some illustrations. And in this case, we try to use type 1 and type 2 fuzzy systems. So I was talking about type 1 fuzzy systems earlier, but type 2, in type 2, we are able to process uncertainty in a much better way. For example, when we say it has a membership function of 0.5 in type 1, in type 2, 0.5 itself is fuzzy. So we need to process that 0.5 using advanced modeling concepts. So basically, we are able to encode and process imprecision in a much better way in type 2 fuzzy systems. And here we see a comparison between type 1 and type 2 fuzzy systems. So type 1, if you look at, the error is 0.0043, and it's reduced to 0.0041 when you move from single to multi-objective. In the bottom row, you see it is type 2, single objective to multi-objective. So you could see that overall, as you move from single object to multi-objective, the error tends to go down, because these are the root mean square error. The lower the error, the better the model is. Okay. So this is another control system. Again, very similar performance. So you'd see that single objective on top, multi-objective on the bottom row. And when you move from single to multi, you could see that error is going down, and bottom as well, single to multi, error is reduced a lot. But in the first case, single to multi, error is almost same. Reasonably, not much difference between using single and multi. But when you tend to use type 2, you could see that error is reduced. This is a practical application where we had 300 features. So when you have 300 features, technically speaking, you cannot use traditional fuzzy modeling techniques. So we try to use this method. This is type 1 and type 2 on the bottom. Bottom left is type 1, bottom right is type 2, multi-objective. So you can see that using only 7 input variables. So it has, original data set has 300 features. So having only 7 input variables, we are able to get an accuracy of 18.66. And using only 4 input variables, type 2 multi-objective system, we got an error of 15.25. So the error got a lot better. So I guess it is time for me to conclude. So basically, there is a lot of convergence between cyberspace and physical space. That is what is all about Industry 4.0 and Society 5. So basically, we try to use the cyberspace as much as possible using various technological infrastructures. And Industry 4 and Society 5 will enable AI on big data and robots more effectively. There is no doubt about it, as we are seeing these things are happening in real life. There are several challenges from AI data science perspective. We need to develop fast learning methods, achieving global error rate, computationally inexpensive. All these are, I would say, some sort of multi-objective tasks. So traditionally, it is not easy to solve them. But over time, we need to find better methodologies, better representations, etc., etc. I would say many a times, especially when you look at data sciences or data analytics, we need to also look at the data quality itself. We need to make sure that data is of good quality, and we need to understand, the features in depth. There could be features that could be providing totally nonsense information, probably sometimes noise, sometimes missing information. So we need to do a lot of pre-processing, a lot of understanding about the problem itself. So many times we need to spend a lot of time for deeper understanding. So I think with this, I will conclude my talk. So thank you so much for listening. I'm sorry that it was more like a broadcasting without much interaction, but I can take some questions if we have time.
Thank you very much, Professor. And do we have any questions from participants, from on-site participants? Okay, so we have two very similar questions from distance from remote participants, and one of the questions is, could you please predict some things for Industry 4.0 in artificial intelligence? What could be very useful in the future, but now looks impossible? It's the first question. And the second is very similar. As we know, Industry 5.0 is already on horizon. Could you please predict the key points how Industry 5.0 will look like, and what will be the new challenges?
Yep, thank you for those nice questions. Actually, it looks like NP hard questions, but I'll try to answer, from the way I understand all these aspects in the best possible way. I think one of the major challenges, like I see it from Industry 4.0 perspective, is modeling the problem itself, application itself, because when things go at a massive scale, for example, when you have thousands of sensors, thousands of devices, and manipulating this data flow from these sensors, abstraction of data from these sensors would be a certain challenge, and that is more like feature processing in AI or in data sciences. But at sensor level, whether it is a robot, whether it is some monitoring applications, etc. But for them, it's a certain big challenge. How can we abstract various data flows so that we could actually minimize the data overload to various processing layers, so it could make decisions more swifter, more accurately, and also we can use more compact models. But handling all this massive information, they pass all the information to us, and we need to process and make decisions. Probably that is not the right way. So I think we should have a top-down approach than a bottom-up approach. Right now, I think most of the information processing are done in such a way that we are processing all the massive information without any discounts. So basically, if you can cut off some of the things at that layer, some abstraction. So probably we need some sort of like something like an ontology, like structure at various layers, application layers, and if you can minimize that data flow to lower layers, that can actually improve. And the second part, from the AI perspective, I guess we are still, I would say, learning many things, right? We say that we have deep learning, we have this, we have that, but still, if you look, like a bit deeper, we are nowhere. For example, we have driverless cars, and for example, if you have a trash bag in the middle of the road, I guess a driverless car will stop in front of the trash bag, telling that it is a rock. Right? We don't have technologies that could distinguish between a similar rock, like a trash bag and a rock at midnight. So we really need to improve our methodologies, our various mechanisms to get in even closer, to some of the way we do things. So there are a lot of challenges. So as I mentioned, getting global error rate, better generalization, developing systems that are computationally inexpensive. So all these are, major challenges from an AI perspective. And how Industry 4 looks like, I guess, to me it looks like the revolution and the automation or the advance in manufacturing, that is potentially going good enough, and probably is good enough. But I think we should also look at Society 5, how we could make use of these technologies to improve our community, our society, our daily well-being. So instead of being stressful, instead of getting all this potential bad things just when you get to some nice age, whether we can improve our lifestyle, whether we can improve our quality of life, being happy, being enjoying all these technologies in the best possible way, rather than developing technologies and throwing it without enjoying what the potential of that. So I think the more challenge for us is to look towards Society 5 than Industry 4. I think Industry 4 is going in a full scale, and we are seeing a lot of massive developments towards that direction. But I think the real challenge for rest of the world is to make use of the potential of Industry 4 for the betterment of our daily life. And I think that is going to be a big challenge. And I guess probably youngsters might see this in a very different way, but I think when you get to some age, probably you look at more peaceful, happy life than seeing a lot of gadgets around you, and you get sick often, things like that. So having a more peaceful, calmful, happy life is more useful than a lot of technologies and under stress, etc. So I think the Society 5 is aimed towards that, and I think we should also look towards that direction in the future. So I guess it answers to some extent, and I guess it is more like a prediction or some ideas, and I think together we could develop a lot of ideas, methodologies to solve some of these challenges. A lot of challenges.
Okay, thank you for answers. Thank you very much for interesting presentation. And now, Jet, could you please to log in for a short interview using the Zoom link which I provided you yesterday. Okay, and for okay, thank you very much. Thank you for Professor Ojit.
So I need to disconnect from this. Right? I need to leave this and join the other link.
You should leave, I think, this environment, and after then join to using this new link.
Perfect. Okay, I can do that. Okay. Thank you so much. Okay.
Have
a good day. Thank you. Have a nice conference.
Take
care.
Greetings from Lithuania. And for others, now we will have coffee break till 11:30. Thank you very much, and we will have a short coffee break. So, let me introduce the chair of software engineering, a special session on intelligent system and software engineering advances. So, Professor Marcin Wozniak. And so Marcin, the floor is yours.
Yes, thank you, Adrus, so much for a great effort on organizing this in very strange conditions. I think we will have the same great meeting and fun as every year, and the next year again in reality. So, again, thanks for introduction, and I'm very happy to chair the session which is oriented on intelligent systems and software engineering. Due to the schedule that Professor Lopata gave me is 5 papers for this session for us. And I just want to check if everybody is here and working. So do we have presenters for first presentation, genetic optimization approach to construct schedule for service staff?
Yes, we have.
We have? Perfect. Is it so? It's your computer, so it's working. I think from the Santaka Valley. Okay.
Yeah.
The second presentation, Donatas, Bartus, and Eligius. I think Eligius is the one on the Zoom.
Yeah.
And Sigma K arrangement protocol for a banking system. Eligius, can you check if you can share the screen with us and unmute yourself? And just to check if everything is working for presentation.
I think everything is okay. So please, maybe
we are starting. Okay, in that case, of course.
And Martin, we have 1.5 hours for the session, and one of participants, ICIST Raudis, the presentation number 4. It informed me that he will arrive after 45 maybe minutes. So
we move, if he's not in the time, we will move him to the last position in this session. In the worst case, he can come to session 2.
Yes, so but I hope that he will arrive on time. So, okay, sure. I invite the first presenter.
Hello.
Hello.
Yeah, I'll just share the screen. Okay. Just checking if everything works. My name is Dalia Chalnerita, and I would like to present our research. Genetic optimization approach to construct schedule for service staff, and this research was based on practical problem. The outline of presentation, of course, is problem definition, objective function definition, and how we designed this algorithm. Then we will talk about the analysis of results and some conclusions which are based on that practical problem. So the objective was, as I said, based on real life, and we had to create the algorithm to construct schedule for airport ground staff, for that staff who perform check-in and boarding operations. And also we had to consider workers' convenience and resources, of course, of those who are employees of employers of those workers. Of course, to minimize costs and to consider those preferences of those who work. Schedule is usually constructed for 1 month period, and we have to distribute a set of approximately 1,000 flights. Each flight requires 2 to 3 workers, and we have 50 to distribute those tasks to 50 workers. As those algorithms usually are very complex, so we had to bound time limit
to construct that schedule, and of course state laws and personal constraints must be considered and must not be violated. The thing is that of course this approach does not allow to construct full schedule, just the main core, and then a person an expert who usually makes those schedules can modify a bit and make all the preferences and make all the preferences valid. Yeah, so this problem is not new, but and it is usually considered in similar areas like nurse rostering, driver rostering, and public transport and others. And of course, there are many algorithms and approaches to solve these questions. However, in theoretical researches, usually we have lack of real-life constraints, lack of considering those real-life constraints. And in this case, we had to deal with such constraints like mandatory working periods and mandatory non-working periods, and include those things into the algorithm. When I mentioned constraints, we had to consider a large set of those constraints. So one set of constraints is state laws, like worker must have at least one free time period of 35 hours in 7 days and similar. And the other ones are more like personal constraints. For example, worker prefers to work a specific number of days in a row. Yeah. So you can see the set of constraints, and this is not actually a full set of constraints we had to consider here. For initial data, we had a table and parameters for each work, besides those constraints, like maximum number of free days, maximum number of working days in a sequence, and one of the most important things is possible task types, so the task types the worker can perform. This set of task types is different for each worker. So basically this is a set of such table of a lot of numbers. And each task, also some information about task type, task duration, and how many workers are required. We had to consider about 2,000 flights, and 52 workers, and you see that we had first group like workers who can perform all tasks, and smaller than those groups of workers who can perform a smaller number of tasks. So I skipped these slides just to show the demand of workers we calculated for each group. So about designing the algorithm, this algorithm was based on genetic optimization, as the title says here, and a greedy approach for construction of individual schedule. To compare different schedules, we had to create some parameters, some estimation, and this estimation was an objective function. And this objective function includes various parameters such as overtime, duration of unassigned tasks, idle time, some differences between between preferred and actual free days. Short working periods are also considered. So these estimation parameters used in this optimization process. This is the scheme of the whole algorithm, but you can analyze it in proceedings. I think I won't stop for long here. Just that all generation of population can be parallelized. The main thing here, I think, is construction of individuals. So at first, tasks are mapped randomly to workers. So we form a task and worker map, and the construction of a specific schedule for that task worker map contains of 3 stages. The first stage is generate like the core of schedule by assigning tasks consequently and considering all hard constraints which must be satisfied. The second stage consists of 2 steps. The first step is to add tasks which worker can perform without modifying the schedule which is already constructed. And the second step of the second stage is adding tasks by extending periods or adding new periods, new working periods for the schedule. And the third stage is balancing overtime for some number of workers. This stage is rather computationally expensive, so we can we perform this stage just for a small number of workers. Yeah, so these 3 stages result in this scheme where we like show it in a more informatical way. And then after we construct a schedule, we have to perform the optimization steps. So this is more or less traditional genetic optimization with parent selection, but we try to use 2 approaches for children, for constructing children. Yeah, so this is again a very complex scheme, but you can analyze it in proceedings, I think. But the main idea is that we use 2 approaches, as I mentioned, and the first approach is to take 2 parents and slightly modify each of them. This enables not to worsen good parents, and just by slightly modifying not to lose the good achievements. And when we modify 2 parents, when we slightly modify 2 parents, we construct a two new schedules for each for each child and select one of those which is better. And the second approach is traditional 2-point crossover for mapping these 2 parents. Task work for mapping tasks to workers. Yeah, so about results. Termination conditions were maximum running time. So it was able for algorithm to run a few days, but we stopped it after several hours. And if results were not achieved, and the most popular termination condition was maximum number of iterations with the same best result, with the same that evaluation of objective function, and the one termination condition which actually was not reached in any way, basically. It was when objective function value reaches the 0. And it's because we also had soft constraints, and we tried to implement better and better schedule. And although hard constraints were satisfied, we still were looking for some things to improve in those schedules. Yeah, so we had here some parameters we used in those experiments. And here we have objective value of an objective function, and we try to compare the impact of several stages, as I mentioned previously. We try to compare it with a standard genetic algorithm with two-point crossover. And here you can see that A case where all stages were included and of the algorithm, and case B where first and second stages were included with both steps in the second stage. And A and B cases were rather similar. We tried to use 5 runs of each case. So you see several examples, but we are very similar in that group of those cases. Of course, C and D, when we try to remove several stages in that algorithm, worsens the results, so we get a higher objective function value and early stopping conditions. And here is an example of a schedule for 4 workers. Of course, it's just a fragment of that schedule, which was constructed for 52 workers. We have some mandatory working periods here in red and 3 days for each worker, for one worker here in gray. You can see those fragments and that they are considered in this case. And to summarize, the main thing I think is that it's very difficult to evaluate the goodness of schedule because for one worker, maybe one worker prefers to work at night and another prefers to work in early hours. So mainly it is more or less a subjective estimate, subjective evaluation of that schedule. So one of the main things here is, like the most complex things here is how to evaluate those schedules. So I think this is the end of my presentation. So if you have any questions, please.
So, okay, thank you. Do we have questions from on-site participants? So, Professor ICIST, Rudis.
Hello. Why didn't you, if you have multiple objective functions, why didn't you use multi-objective or genetic algorithms for optimization? There are quite a few of those, like NSGA or something too, NSGA for free.
Yeah, so there are several things here. We had to, we wanted to generalize those functions and those things. It's a great idea, and I think we will try those algorithms in future researches. Again, it has to work it's more or less for practical solutions. So again, we have to consider several constraints, and the limitations of those algorithms maybe are not so great in evaluating those limitations when we have to include mandatory working periods and so on. This was one of the cases in practical problems.
So, thank you. Do we have more questions from outside participants? No? Thank you. Marcin?
It was great presentation. I just want to ask you for one idea. Have you tried any other models or methods to solve such scaling problem?
Yeah, I'm not sure I understood.
Could you please repeat your question, Martin?
So, have you tried any other algorithms or models applicable to this solution?
Not particularly. We did some research and we tried to find the best thing. And actually, it is not a part of scientific research, but more or less like someone comes here and asks for a quick practical solution. we did we chose the most safest one, but as it is, as we see the need of these researches later, now we have another research on this topic, and I hope I will be able to speak about the conclusions about that research in the next year.
Okay, sure.
In this conference.
Thank you so much. Sure. So now is the time for next presenter, Sigma K arrangement protocol for a banking system.
So thank you for that. The certificate.
Hello, everybody. I will present one partial result, intermediate result. We are dealing with the problem of e-banking system, and together with key agreement protocol, it is necessary to provide some identification or authentication method. So our authors are displayed there. And I would like to start from one report in Euronews in 2015, where the first sentences like Swiss mental cheat, the ways your online banking accounts are protected might be full of holes. So it is, this interview was very strange for me, since banking sector is very responsible to avoid any panic in finance market. But nevertheless, this report appears, and it is a little miracle. And why it appears, I think that despite the 20-15 years, these problems are active so far. So in this report, there were pointed out that 1 million euros one firm has lost, and this loss is due to a weak identification or authentication in the part of the customer, How it is happens in this report, you know, there are Trojan horses which infects your computer, and there is some scheme how this infection was carried out. It was opened some picture in the email, yes, but there are some darknet, where these Trojan horses are sold, and at this time they cost 1,000 euros. It is, of course, interesting report. I'm not intending to read it in total, but nevertheless, there is pointed out that bank client is a victim, is always a victim since the treaty between customer and bank is written in such a way that bank avoids any problems when your money are lost. So our paper deals with the identification protocol compatible with Diffie-Hellman key agreement protocol. Yes, and this protocol is used to any e-banking system. And what kind of attacks are arranged? So there are, say, Alice and very lazy Bob representing bank, but in the middle there are a very angry witch. It is an evil by itself and evil without any reason, simply it's evil. And this evil infects computer, and if Alice and Bob are executing, say, SSL TLS protocol, so this witch is interrupting this protocol. It is an active adversary, and all the communications are performed between Alice and Witch and Bob. And so this creature, I don't want to name it as a person, this creature impersonates Bob against Alice and Alice against Bob. So it is the part of HTTPS protocol executed in any e-banking system. And of course, it was full of holes. And I am surprising in our society level. So despite the fact that our Minister of Internal Affairs is distributing personal cards containing public infrastructure, but penetration of this technology is very low, and therefore there is a place for such an impersonation and causing big disasters. Now there appeared some better way for identification or authentication, i.e. identification dedicating to the person identification and authentication to the data authentication. Smart ID method, of course, it is some method having some advances. It is 2 channels for identification, but I think it is temporary measure. I will tell a little about the future, how I am imagining it. But now we have proved one simple theorem that by joining Diffie-Hellman key agreement protocol and Schnorr protocol, we transformed Schnorr identification protocol to Sigma protocol, and we have proved that this Sigma protocol is non-vulnerable to the man in the middle or impersonation attack. And there is some conditions. Alice is prover. She has to prove his identity. She is using her private key X and public key A, and verifier is bank, and bank has Alice public key. So bank is sure that on the other end of communication channel is nothing, nobody else as Alice. So despite the fact that the penetration of public infrastructure, the cards containing, identity cards containing personal data and public infrastructure are not distributed, so banks should supply their customers, for example, with mobile application providing such an identification method. Since we have combined Schnorr identification together with Diffie-Hellman Elgamal type identification, public parameters are the same, and our identification and key agreement protocol was quite effective. So it could be effectively realized by, say, mobile phone having sufficient power in mobile phone processor. Now, what about the future? I have read a paper written by Wozniak, Professor Wozniak, Domashevich. They are investigating biometrics, but they dedicated this biometrics they use biometrics of electrocardiogram recording, yes. I have found a paper of 25th year, don't remember now the author, which was cited, I don't know, about maybe more than 800 times. And the other reliable, I think so, identification method is an iris identification. So it is not two-factor, but two methods identification when powerful cryptographic methods should be combined with biometric identification methods. And I think so. I prefer that these methods could be iris identification methods. So the future is, of course, two channels, maybe two channels identification through directly connected internet from our mobile phone or computer, and through the mobile communication channel, GPRS, I think so. And therefore, I believe that these methods identification will supply with strong cryptography using biometrics, and so the e-banking system, the blockchain systems, which are very evolving very rapidly, using smart contracts, using token. Future will be about token economy, etc., etc. Future will be linked with initial coin offer, investment tools. So there will be some problems to be solved. First of all, it will be authentication, but together with that, the big problem is anonymity of blockchain technologies. And it is also valid for a banking system. For those users, authentication should be maintained at the highest level, but for the side users, all transactions data should be maintained not achieved, maintained anonymous. I have student in doctoral students, and we will solve these problems to get how to synthesize together two problems. First of all, authentication problem, and secondly, anonymity problem. I expect we will provide some solution, and not only for a banking system, but also for blockchain technologies. So thank you for your attention. Maybe you have some questions to me.
Okay, thank you very much. Do we have questions from the hall? Okay, just a moment.
You said that, well, you've mentioned that biometric authentication methods can be helpful in identifying the people, and using, for example, an iris can be also helpful. Well, as far as I know, for example, there are some pictures publicly available on Facebook or somewhere else, and if you are a famous person, there are even more pictures available. Do you think could the hackers use these publicly available pictures of an iris, let's say, or face to trick the system while they hack these biometric measures?
Yes. I'm not specialist in biometrics, but I have read some papers. Of course, if biometrics is seized, yes, so the subject will not change its iris picture, but in this paper I have mentioned the iris picture is combined with some random data, and so prevention of stealing the biometric data, says fingerprints or others, are not working. So this protection, toward this protection, some efforts are made. And I think the positive solution will be achieved, and these methods together with cryptography will be applied in future, I think so.
Okay, thank you. More questions? No more questions from Kaunas. Martin? Martin?
I just want to say that this is a very demanding topic, and this is like very hard for solving new solutions. So I just want to share congratulations with the presenter to aiming with the demanding topics and aiming for very important research in the future. So it's just like sharing congratulations with the chosen topic.
Thank you very much. Thank you.
That's all. That's all. Thank you.
Yeah, thank you.
Okay. So now we will have a remote presentation. Do we have a presenter connected?
Yes, I'm here.
Okay, great.
So we have a table header correction algorithm based on heuristic for improving spreadsheet data extraction, and we have Vyacheslav. Hello, Vyacheslav. How are you? Next. Nice to see you. Virtually.
Hello.
Yeah,
nice to see you too.
Virtually. So
yes.
Please do the presentation for us.
Okay, thank you very much. Thank you so much for the possibility to do a presentation in these hard conditions of coronavirus. So I want to present our research. The outline of our research is on the slide. I tell about background, the research about spreadsheets and the algorithms to recover a structure of the tables, and I'll do some conclusions. Well, the problem which we research have deal with the table understanding. It's a area to getting information from tables and automatically understanding the content of the documents of the tables. And spreadsheets now is one of the most commonly used form of representation information in domain-specific datasets. And also we may tell that a huge amount of these kind documents are available via open access in the web. And typically, this kind of documents created by people and for people. So it is hard to process them automatically. And a lot of these documents presented in Excel format. It's one of the most common formats that used everywhere. And some studies report that every day we have more than 1 million documents in Excel format. So we may tell that Excel is a widespread distribution software of the document processing. It's one of the form of data organization and representation that easily readable by people. And this kind of document and format document allow to organize data in various domains, and also a lot of statistical and analytical reports, which are good basis for data integration and analysis present in Excel document format. So it is a very important task to have the possibility get information from tables in Excel. We have some challenges when we want to get data from tables. We should identify a structure of tables. We should make correction of cells structure. And after that, it will be possible to apply algorithms for automatic data extraction in Excel tables. And in this slide, bold font is demonstrate steps which we did for getting data in our approach, in our algorithm. Different studies report about different blocks of the table. However, we try to get general information about conditions about blocks of tables. As a rule, tables have metadata, the additional information about worksheet, about data specification, table specification, and so on. Cells have header, it's some kind of labels of data. Tables have a hierarchical structure, and data that is a field of interest for processing. If we have correct information about header, we can correctly get data of the table. However, as I told a couple of slides ago, tables created by people and for people. So in visual, we may have one picture which is different from physical presentation of the table. In this slide, the visual example of visual layer is shown. And you may see that it is different with physical layer. Physical layer is real cells of spreadsheets. And the idea of our algorithm to realize an approach that allow to bring physical structure of table header to its visual. We divided cells of header into categories. That cells that don't contain any data. It's empty cells, and another cells which have any information, which we call non-empty cells. We did some assumption of our algorithm that header always have a hierarchical structure. There are no empty cells in visual layer of the header, and cells in physical layer can be merged according to visual representation of the header elements. And also, if two adjacent vertical cells have equal left and right borders, these cells should be merged. For example, left cell in column 1, row 2 and row 3, it should be merged to one cell. In our algorithm, we pay attention about visual borders. We assume that it's a visual line of any style, and if any cell have a visual border, it's a sign for us that the merging of cells is impossible. We take into account cell width, it's a number of merged cells in horizontal direction, and cell heights, it's a number of cells in a vertical direction. A single non-merged cell always have height and width is 1. Header width equals with table width and couldn't be more than table width. Also, we think that upper cells are no wider than lower cells. It's an idea of hierarchical structure of statistical documents, of tabular documents. And each cell in the visual layer of the header should be non-empty, so we can get structure in physical layers that have no empty cells also. And cells of the top level have vertical borders that coincide with vertical borders of lower level cells. Our algorithm consists of 4 main blocks. Firstly, we try to expansion cell in horizontal direction. After that, we try to expansion cell in vertical direction. The horizontal borders of this merging set the borders for cells in lower levels. And then we continue operations of blocks 1 and 2 in block 3 for horizontal processing of cells, and apply the iterations through the vertical borders of cells. The illustrative description of the algorithm presented in this slide. For example, firstly, we get cell 1.1 and move to horizontal direction, merge with cell 1.2, move to vertical direction because we have a border of the table. And according to our assumption, merged 1.1, 1.2 cell have the equal width with cell 1.3. We merge these cells. And in the same way, we process label 2 cells 2.1, 2.2, and cells 3.1, 3.2. And the result of the physical presentation is shown in the lower picture. Example of the transformation presented in this slide. In the upper figure, we have a presentation table structure visually. The dashed lines, it's physical lines of the cells, and user don't see it, but it is possible to estimate the structure of the elements of header. And after the correction, we will have physical structure of table according to our visual representation. To estimate our results of our algorithm, we made an experimental evaluation. We used a South dataset for our experiment. We got 200 tables selected by George Nagy, and apply our algorithm to recovery structure for these tables. In order to estimate the accuracy of and quality of our algorithm, all these 200 tables were processed automatically by an expert, and after that we estimate results. It is need to highlight that sometimes in some tables, experts have different ways to merge cells because of structure of tables allowed to apply cells left to right or right to left. And so we got three data sets, an original data sets of South, which had more than 8,000 cells. After the correction, physical structure of tables of that 200 tables, we got 3,800 cells. And after manual correction, we got a result 3,846 cells. And the number of identical cells in datasets B and C is 3,730. So evaluation results of our algorithms are presented in this slide. And in our research, we have demonstrated a heuristic approach for structure correction of table header. And this approach allowed to prepare table header for further analysis, and it will allow to improve the results of data extraction in this area. Thank you very much for your attention. If you have any questions, I will glad to answer them.
Thank
Do we
you.
have any questions,
Yeah, do we have
suggestions
questions?
to Vyacheslav?
No, we do not have questions from Kaunas.
So I maybe just ask some suggestion to you. Have you thought about possibility to transfer your model to any other systems or solutions?
Yes, we thought about it. Currently, we had a tool, Tabby Excel, and we appropriate this approach to our system. However, its system is free access in GitHub. I'm so sorry that I didn't show the link to this system. But it is in the paper.
Okay. Sure. Any other questions or suggestions?
One more question from
I think no.
Kaunas.
So thank you so much for being this year. Please also be the next year. I hope in reality. So would be great.
Thank you very much.
Great to see you. Thank you so much for presentation and for being. See you.
Sorry,
Bye.
we have one question from Kaunas, okay?
Oh, there is one question. Super. So wait.
Okay.
It's not a question, it's more like suggestion. I like the way you transform Excel tables, which usually are messy, but one more useful step forward would be to, when you have a header of, let's say, 3 lines, yes? And some first line is some very large, broad category, and then you have other names below. When you merge them, you could additionally concatenate the names so that in the end you have a table with a header which is of 1 line. This is very important in machine learning and those fields where you just have a table with a 1-line header nicely connected with semantics which were in the names.
Excuse me, please, there is some echo and I couldn't clearly hear your question.
Okay.
Just a moment.
Can you hear now?
Yeah.
Yeah? Do you hear it?
Yes.
When you have this hierarchical structure of, let's say, 3 rows in the header, and then you reconstruct it nicely, clean it out of all the lines, then you could connect the names. First header, large category, could be connected like a string. You can glue the strings and make a very long name, which gives you of the last row, and then you could in the end have 1-row header. 1-row header with semantically meaningful names. After you concatenate upper categories.
Yes, but currently we didn't pay attention on the semantics. However,
yeah, I understand, but when you have a table which is nicely done with 1 header, it could be used further in analysis, in data mining, in machine learning. Because these headers we showed cannot be used straightforwardly. You have to decide on the name for the column. And to construct this column name, I would suggest to concatenate above names.
Yes, we, well, if we, when we merge some cells, we try to store the styles of the cells.
Yeah, I saw you could concatenate the name from above the cell, but if you could concatenate even bigger name with the top category, like global category, then dot or maybe space or some symbol.
The categorical analysis of the cell, it's a good question, and we think about this on the next steps of our research. Currently, we didn't pay attention on the categories, and if you tell about the names of the cells, in these data sets, we had statistical data of different areas of United States, and that Excel documents workbooks didn't have any information about
the
cells,
thing I am
about
suggesting is
names.
very simple. Let's say you have males and female statistics for births, yes,
Yeah.
and for deaths.
Yeah.
So you have one line which is first line births and deaths, and the second row of the header is male, female, male, female. So to give this data for machine learning algorithm, for example, for analysis, for further analysis, you just have male, female, male, female, which are not unique names if you take the last row only. But if you put up that upper category and flatten this from 2 rows to 1 and preserve unique names, that's my suggestion.
So, thank you for this question.
Okay, thank you very much. Thank you. And
Thank you.
now we have on-site presentation, and presenter is Professor ICIST Raudys.
Hello.
Hello, nice to meet you. Please present. Hey.
Okay, so today I'm going to present a review of self-balancing robot reinforcement learning algorithms. So the problem of two-wheeled robot and the balancing problem is known for quite a while. It's been solved so far quite successfully, and everybody knows things like Segway, you know, and all other devices on the two wheels. But the idea of this project was that majority of the algorithms used for self-balancing are human-coded. So basically, a human put their knowledge into the model and basically program that if a robot is falling into one direction, it should start wheeling one way or the other. Okay, sorry, I forgot to do screen sharing. Yes, so basically, all the algorithms for self-balancing robots are human-coded. So basically, human encode all the rules inside the program. So if the angle of the device is falling to one direction, it should start rolling, you know, forward to compensate this this problem. The idea of this research was, instead of having humans to program the logic of the self-balancing, let the algorithm themselves learn all this information from the environment. So for this study, the two-wheeled robot is based on the pendulum model, inverted pendulum model, and was chosen as the model for studying reinforcement learning algorithms. It has a simpler mechanical structure and simpler dynamics than bipedal robots, which also encounters a self-balancing problem. So here's one of the examples of application of this self-balancing robots, which can handle carry the passengers in the city. So let's formalize the problem. So the goal is to keep the robot in the balanced position while standing on one place or moving. And the goal is to keep the standing of a place at the angle to be kept at 90 degrees. So basically you have to stay vertical. And the goal is to keep moving forward, and the goal is to keep the angle less than 90 degrees. So the aim of this study was to investigate what sort of neural networks and robot balancing using reinforcement learning we can use, and to test and compare different reinforcement training algorithms of two-wheeled robots for balancing problem. So basically the idea is that if the human coded algorithms cannot code all the details about the environment. So, for example, the wheels may be on the slippery surface, and they may slip, and all this information have to be taken into account. And not always it's possible to take into account all this information, and if you allow the algorithm to learn themselves, it can be done probably much better. So basically, I'll quickly introduce you reinforcement learning. Reinforcement learning is a system that learns from the environment. From classical machine learning, so you have the input and the output, and your aim is to create a model which would map the input parameters to the specific output. With reinforcement learning, it's a little bit more difficult. It is designed to solve different tasks. Imagine a robot which needs to move from one direction to another. So there is no clear relationship between input and output. There is a robot, he is sitting in one position, and it has to make a series of actions, and at the end of the series, this have to be the target where the robot must go. So it's not really clear, but typical machine learning algorithms cannot solve this sort of situation. That's why they invented reinforcement learning. In reinforcement learning, robot does a lot of different actions. Each of them is leading to the global final result, and robot gets a reward for every action. If he does a good action, let's say he has to travel from this spot to this spot, if a robot moves into that direction, he gets a negative action. If he moves towards the target, then he gets a positive action. And if there is some obstacles in between, he has to learn to actually how to overcome them and go around them. Okay. So the object is told which actions needs to be taken, yeah? And such learning takes place by the agent testing out the actions and defined for him. Here's a little illustration. So you have do you see my mouse? Okay, you see. Yeah, so you have the agent, you have environment, and there is an action. So for every action the agent takes, the environment generates him the reward, and then the environment goes into the different, environment gives a different state where this agent is, the state of the environment. So let's say the first state that the robot is located here, the second state that the robot is located here. So the environment changed around the agent. So to summarize the reinforcement learning versus machine learning, with machine learning, you have very clear and easy relationship between input and output, what you want the algorithm to achieve. With reinforcement learning, you have an input, the starting position, then you have a series of unknown actions this device or robot has to take, and then you achieve, and then you finally reach the output. So it's very different concept. Reinforcement learning policies. Reinforcement learning policies are something which allows the reinforcement learning algorithms to make decisions on the actions. In this research, we tried a couple of neural networks: the classical multi-layer perceptron, and also time series type of neural network, long short-term memory neural network. We examined 5 different types of reinforcement learning algorithms: deep Q learning, actor-critic learning, TRPO, ACER, and PPO. So the first 2 are more or less like standard algorithms, and the latter 2 or 3, they are a combination of these different features which are incorporated in the first 2 algorithms. I'm not going to go into very details. If you will be interested, you can have a look at the paper and also read the referenced papers which are talking about the details of these models in more detail. So let's look at the robot and the environment. So we didn't have actually a real robot in this research. We used a simulation. We used OpenAI Gym to do the simulation. We had a standard acceleration speed in this environment of 10 meters per second. So this is very common way of solving this type of problems. Typically, researchers, when we do some robotic stuff, we don't jump into the actual physical robot straight away. We create this robot in the virtual environment, and we run some simulations. So we had 9 different actions which a robot can make. It can start, it can move faster by 0.1 radians per second, 0.2, 0.5, and 1 radian per second. It can also do exactly the reverse. It can start going backwards by the slow down by 0.1, slow down by 0.2, and maybe go in the opposite direction. So the environment is the tilt of the angle and the angular velocity of the robot wheels. So rewards was calculated by using this formula, which I'm not going to go very detailed because of the time constraints. So the robot in simulation, you can actually try to visualize it. It looks very simple and nothing really fancy. Its weight is about 0.8 kilograms and the size of 20 by 5 by 40 centimeters, the body itself. And then you have the wheels, which were additional 0.1 kilogram and in 10 centimeters in diameter. So you can create in the virtual environment the robot like this and then fully control it and use any algorithms you want, and it actually responds to real life physical conditions. It falls down, it obeys the laws of physics, and so on and so on. So as a result, we were able to teach the robot to self-balance. So imagine here, we don't tell the robot how to do the balancing. We just tell them, you have to balance. Yeah, we tell the robot the final target it has to achieve. So we don't incorporate any rules inside this algorithm. The algorithm itself learns what it needs to do in order to stay upright. Yeah, it learns. So for the best robot, I think it has to fail in simulation about 100 times approximately until it actually learned how to stay vertically. So it could be very similar to actually a human baby, yeah, who just doesn't know how to walk and stand, and after multiple times of falling, he actually learns how to keep the balance. So it's a very similar problem. So here we have, this is a result of after the training, when the training is finished. So for 1, 2, 3, 4, 5 different models we tried, didn't manage to stay upright, and 2 of them were quite successful. This is only using my multi-layer perceptron as a policy. And this is how the balancing, this is the speed of the wheels. You can see one algorithm's DeepQ with MLP was much more stable with much fewer bending, left and right, and why PPO method was actually moving much more. A second group of experiments were done with LSTM neural networks, and we were more successful here. We managed to get 3 of the 5 algorithms to be able to learn how to stably keep in the upright position, also with different amplitudes. This is the angle of the robot Earth's body. So you see it's actually with the blue line. You see that it's shaking quite a lot to the left and to the right. The most stable one is DeepQ with LSTM is actually only using only wobbling quite a little. And this is the same graph of 3 models, but the results of speed of the wheels. So how fast it's actually trying to correct the position and keep it in the upright position. So here's a summary of the experiments. So we have different policies of multi-layer perceptron and LSTM. The differences between the two is that multi-layer perceptron doesn't look into the past. He just takes the current state of the robot and generates the policy, the action it needs to take. LSTM is as a time series neural network, which takes into account the previous behavior, previous positions of the model. So basically with LSTM, you take into account the history. And as you see, the LSTM was performing a little bit better than multilayer perceptron. This is the total number of tests we did. And this is the range of the tilt angle. So for minimum and maximum, the difference between minimum and maximum, the angle of the wobbling of the robot, and this one is a wheel's angular velocity. So basically how fast were wheels going forward and backwards to stabilize the position. Okay, so this is the summary of the results. We tried 30,000 steps for one group of models, and then also some of the models didn't manage to learn, so we also tried to do a 50,000 to keep them training longer, and only one model managed to get the better results. So DeepQ using LSTM method was quickest to learn for self-balancing, and it took only 92 falls. So basically from the robot who knows absolutely nothing what to do, you know, you tell them, I don't know how, but you have to learn to keep yourself vertical. And it took only 92 falls. So the robot actually tries to move this way away and then fall until it actually managed to learn how to stay in the upright position. So we have conclusions. So we have different models, different methods having different features, and LSTM, as I mentioned, it doesn't have history, doesn't look into the history. LSTM looks more into the historical position of the robot, and it was actually generating a little bit better results. Also, it's worth mentioning that this simulation was done, this experiment was done in simulation in the virtual environment, and in reality it might be a little bit different because of a lot of different factors. The machine motors may not be able to rotate that fast and change their direction that quickly, and so on and so on. So here's my presentation. Thank you very much for your attention, and maybe you have some questions.
Okay, thank you. Questions? Okay, we have question.
I'm just curious, how long does it take to train a robot, the one which knows nothing, to fully well trained?
You mean in like physical time? Obviously, it depends on the computer, on the power of your computer, but it's a matter of tens of minutes. Like in half an hour, it could be pretty done. And also, as you saw in one of the slides, for the best model, it took only 92 falls. So basically, you run the model in the simulation, it falls down, and 92 times it actually falls down until it learns how to balance. It should be very similar to actually human babies, no? How many times a human baby have to fall until he learns, to keep a balance in the upright position.
Okay, thank you. More questions? We do not have... Oh, one more question, okay.
Very short one. Could you reuse this model as a pre-trained variant for real robot? I mean, you train it on the model, as you did now in simulation. If you have a very good model, very realistic physically, is it possible to use it in that you simulate those 92 falls and then you put it in reality and it doesn't fall, maybe? I don't know.
Yeah, that is the typical flow of experiments like this. I mean, typically then people play with robotics. They create a virtual robot in the environment. They do some experiments and training first because a physical robot is much more expensive, you know, and it takes much more longer. And then we try to move the virtual environment into the physical environment. There are always some problems because the real environment is not exactly as the similar, but at least a bigger amount of learned experience can be transferred from the virtual environment to the real. So you're right. This is it's in most cases it's not working like straight away. Yeah. You have to do some extra work and actual training on the real environment, but it is very big step forward, you know, to train it in the virtual environment and then move it to the real.
Okay, thank you. We do not have more questions here. Martin?
I think no, it's a good presentation, also involving topic. This is two-wheeled robot, so it's not so easy to operate because there is also a problem of balance. So that's a great idea, and I wish you great success with the robot in the future. So thank you so much for presenting.
Thank you very much.
Your certificate.
Okay, so we have the last presentation in this section. It will be a remote presentation. And do we have presenters online?
I think yes, because Guillermo is with us online. Hello.
Hello, how are you?
Hi. So
Hello.
the next presenter is exploring web services quality of service estimation for web service composition.
Hello, how are you? Can you hear me?
Yes, I do. I think the rest also. So.
Yes, Kaunas hear you. And see you.
Okay. You see my presentation?
Yes, we see you.
Okay. Good morning, everybody. My name is Guillermo Rodriguez from Argentina. And on behalf of the author, I'm going to present this paper entitled Exploring Web Service QoS Estimation for Web Service Composition. This is the agenda of my presentation. Firstly, I will introduce our approach, then the motivation to carry out the research, then I will present the approach, then the experimental results, and finally, I will outline the conclusions and future lines of work. Okay. Firstly, I'm going to present what are web services and what are they for. A web service is a piece of code that is responsible for a specific functionality and can be accessed using standardized network protocols, for example, HTTP. The problem is that there are countless web services available, each with a specific functionality. In this context, the composition of web services allows combining the functionality of different services to achieve more complex functionality. The available web services are constantly changing, as some services are removed either permanently or temporarily, other new services appear. So, web service composition is a hard issue, so it's important to know what requirements can make a good service have good quality. Then, in this context, our motivation is there are no works in a literature review that allow estimating the quality of web services from the perspective of complexity, size, or quality of its interface. For us, it's crucial to estimate the quality levels of the attribute of the candidate web services to compose based on the interfaces of these web services. Thus, choosing the services to compose that have the best quality implies a better performance as a result of the composition. For this reason, our approach, in this approach, we intend to estimate levels based on the values of the metrics of the interface proposed in the SNID catalog. Then we explore multivariate linear regression, where the dependent variable is the level of a quality attribute, and the independent variables are each of the metrics proposed in the SNID catalog. So we state this following research question. In that context is it possible to complete missing information on either web service interface metric or web service quality attribute levels? So this is our approach that we carry out in the context that we not always have all the information available of web services, for example, the metrics, interface metrics, or quality attribute levels. So our aim is to predict some missing information when the information is not available for us, either interface metrics or quality attribute levels. The first approach, or our first attempt, was the information of interface web services or metrics related with interface web services will be provided by this software that is SoftAudit. That's software that was developed by SNID, and the author gave us in some time ago. With this software, we can get web services or files written in WSGL protocol, that is a documentation or a specification of our web services. Since with information, we can obtain the interface metrics of the web services. Okay. On the other hand, we have the dataset with Almasric metric, that is a QWS dataset publicly available. So we merge this information because Almasric dataset has the information of quality attribute levels of 2,100 web services. And this dataset also provides the URL for that web service, so we can download the file of web service, the description of the web service, and give us input to the SoftAudit to obtain information about metrics of interface. So we use Canin to merge the dataset of catalog metrics and public attribute levels and get a full merged dataset. Then give this information as input of a statistics soft that is similar to SPSS of IBM. That Infostat is an Argentinian software developed by a public university, and this software has the same or similar in functionality that SPSS of IBM, and then obtain the linear regression models under all the assumptions required by the linear regression models, and we test that that regression models according to the R-square adjust. That is our indicator to evaluate the quality of the linear regression model. So we test our approach in experimental result. At the case study, we use as said before, a publicly available quality of services QWS dataset from Almasri that is publicly available. And the dataset have been utilized by related study that consists of a set of QoS measurement for 2,507 real web service implementations. And this is the SNID catalog metric that can be calculated by the software SoftAudit. The metrics are classified into 3 groups, and the groups are service interface size, that are the 5 first metrics, then service interface complexity, and then service interface quality. All these metrics can be obtained by the soft update given as an input a WSGL file. That is the form of description of a web service. And this is the data set. Yes, is the header of the data set provided by Alsmasri that have the response time of our web services. Availability is the number of success invocation by total invocation. The throughput, number of invocation for a given period of time. Accessibility, number of response by number of request message, and you have on the right the unit or the magnitude. Reliability is the ratio of the number of error message to total message. Compliance, the extent to which a WSGL document follow the required specification. Best practice, the extent to which a web service follow the basic profile. Latency is time taken for the server to process a given request. Documentation is a measure of documentation, for example, description tags in WSGL. WSRF is web service relevant function. It's a rank for web service quality. And service classification, levels representing service offering quality that go from 1 to 4. The name of the service and the address of the WSGL in order to locate this service and download the file. So our first attempt was to conduct or to obtain a correlation matrix. In this heat map, we can see the relationship between the metrics in the X. In the X, we can see the metrics of the catalog from SNID. That is the metrics related with web service interface. And in vertical axis, we can see the attributes, quality attributes from the Alsmasri dataset. In this heat map, we know that there is no relationship between these attributes. We can't see any strong relationship according to the coefficient of Pearson. So we observed that there was not considerable correlation between the metrics proposed by SNID and the ones proposed by Alsmasri. So we decided to study each group of metrics separately, and we found a strong correlation. So we merged the data set, and we in the same data set we have all the information because the merge was performed using the web service. So the same information or the same web service that we use to obtain the interface metric and the same web services that is publicly or that is present in the dataset of Alsmasri. So we merge all the information related to that web services according to interface metrics and quality attributes, and we cross together, and we then carry out a correlation matrix, and we can say that in the heat map the strongest relationship is inside the group of metrics. So quality attribute metrics with quality attribute metrics and interface metric with another interface metric. It's impossible to see a relationship between one metric from one group and another metric from another group. So considering its SNID metric, we propose to predict metrics belonging to the service interface quality group from the metrics belonging to the service interface size and interface complexity groups. The best linear regression model, we found several linear regression models, but the most important or the most remarkable is the following: that interface modularity can be obtained since interface structure modularity. Okay, and the other equation is that interface modularity can be obtained from interface data complexity and interface structure complexity and data flow complexity and language complexity. In that context, what what is our objective. So in case that we can't get all the required information about metrics of interfaces, and we obtain or we have some of the information, we can complete the missing information. This is the aim of the linear regression model. Secondly, as for the quality metric from the ALS-Mastery dataset, the best equation was the availability can be predicted or can be obtained from the successability of the web services. Yes, so in case that we have the accessibility of web services and we don't know the availability, we can obtain that information from accessibility. So, as a conclusion, we present a series of linear regression models to predict web service metrics, thus alleviating the burden of web services QoS assessment. Linear regression models were developed to detect patterns, forecast performance, and draw conclusions, back it up an input dataset, either or a QoS dataset, for example, as Mastery, or a SNP catalog metrics dataset. As future work, we propose to explore artificial intelligence techniques such as association rules, neural networks, and clustering, among other methods. And we propose also to collect information from various databases containing quality information from WSGL files to see whether a correlation analysis relationship can be identified using the SOFOD tool also. Okay, thank you very much for your attention. I'm available for any further questions.
Thank you very much. Do we have questions? No, we do not have questions
Thank
here
you.
in Kaunas.
Okay, I see Andrus is coming. So questions from Kaunas?
No, we do not have questions here. We do not have questions here, Martin.
Okay. So I just want to ask for just maybe like a technical question. Mainly online services are now transferable between different web browsers. How is that in your case? Is that solution transferable between different web browsers or web connections? Have you tried it? How is it in your solution?
Yes, okay. Thank you for your question. And yes, it's available because in this analysis, we don't care about the protocol or the browser because we analyze the WSG file. So if we can obtain that document from any digital repository, we can make this analysis because we perform the analysis offline, and the linear regression model is conducted offline. So we don't need or we don't care about the web browser because the main object is the document of the specification of the web service.
Okay. So it's beside, outside the protocols. Okay.
Yeah.
So thank you. No more questions from me. I think if we don't have any other question from Kaunas, we can congratulate Guillermo for being with us and delivering great presentation.
Thank you for the organization and allow us to be part of the conference in this pandemic situation.
Yeah, very hard. I hope next year will be a normal, regular conference in Lithuania so we can all meet again.
Yes. Thank you.
Thank you.
Thank you very much. So thank you for presenters. Thank you, Martin. So now we will have a lunch break.
Okay, 2:30 p.m. We're meeting again for the next part of presentations and talk. Thank you so much for having time for us. See you. Bye-bye.
So Marcin, are you here? Hi Marcin, are you here? Hello? Marcin, do you hear me?
Yes, yes, hello, I hear you.
Oh, great. So can you start?
Of course, of course. So, the second part of the session of intelligent systems and software engineering, we've got here 6 presenters. And we are starting with the first presentation, random forests and homogeneous granulation. And Piotr Artemiev, please, the screen is yours.
Thank you very much, Marcin. Good morning, Professor Opata. I would like to share my presentation. Just need a few seconds. Is it visible?
Yes.
Yes, exactly. Perfect.
Okay, thank you very much. And the audio is okay?
Audio is okay.
Thank you so much. For introduction, it's work about granular rough computing. And wait a second. Wait a second. The plan of presentation is as follows. I will show you some motivation to conduct this research, in a few words in introduction, describe used methods, and show you some experimental works and conclusions. And first of all, our motivation was the recently developed technique for approximation of decision systems, and it's good time to introduce few words about approximation decision techniques we used in our research. Basic idea is to lowering size of the decision systems using granules. Granular rough computing, it's a recent paradigm in which we deal with granules, the groups of objects, similar, collected together based on some similarity measures. And computing by granules, we can approximate decision systems by covering these decision systems, find some representation of system based on covering granules, and we lowering the size by connecting the granules in some strategy in some way. And this is the basic idea of our granular methods. Our granular techniques are proposed by Professor Polkowski in 2006, and I'm working in the group where the first author, Krzysztof Ropia, is my coworker. We developed these techniques, and one of the recent techniques we developed, as I remember in 2018 or 19, is homogeneous granulation. This homogeneous granulation find application in approximation of decision systems, and what was surprising, these techniques don't need any tuning of classification parameters, because it's dynamic. Dynamically work with some kind of with the homogeneous granular technique works dynamically on the specific decision systems with some internal indiscernibility ratio. So the parameters are tuned in automatic way based on this internal indiscernibility. And we use this technique with ensemble model in ensemble of granular reflections and in approximation of decision systems, works fine. And the next step proposed by Krzysztof Ropiak was to check how it works with random forests. And we would like to check if random forests increase effectiveness of decision system classification after approximation based on our granules. So here I have some theory based on these granules. Basically, the meaning of this theory is as follows. Considering some decision system U, A, D, where U is universe of objects, A is the set of conditional attributes, and D is decision attribute, we can compute granules based on rough inclusions. It means that we collect around some central objects, collect objects from decision system which are indiscernible in some radius. This is the number of indiscernible attributes. Wait a second. The number of indiscernible attributes divided by the number of attributes in the conditional set, and you can obtain the similarity measure between central objects and the other objects. And fulfilling this inequality, you can collect around central object, collect some similar objects and compute based on them. And this is the basic idea to create granules. It's simple, maybe not nothing new, but the new is the way we use these granules in covering the decision system. Collected granules cover the decision systems, and in plain words, just we put the granules on the decision systems and try to find representation of decision system, like by random choice, by minimal length granules first, by maximum granules length first, by average granules length first, and so on. There are at least 20 techniques to cover decision systems, and we get the representation of the system after covering. After all granules represent the whole decision systems, we obtain some approximated smaller decision systems where objects are created from granules based on some selected strategy, and this small system in some way contain the internal knowledge which led us to classify in a good way. So the homogeneous technique is defined here, but I show you just two examples and try to describe how it actually works. And this is the theory based on this technique, but I show that two example. The best way. Let's consider the decision system like this. This is classic inline data set. Here we have the objects, here attributes, conditional attributes, and decision attribute, and approximation based on computing the granules on each central object. Let's start with the first object, U1. And computing the approximation, we set firstly the radius 1, which means that the objects are indiscernible in case they are totally indiscernible, so, which are the same on each attribute. And as we can see, this is only one object. After checking if any of the objects is the same, we check if the decision is the same. In this case, we have to we try to lower the radius. Okay, we're lowering radius to 0.75, and now we need only 3 attributes to be indiscernible with some object in the system. And as you can see, in this case, we always don't have any object similar We have to check all combination without repeating of these objects. But in this particular system, we don't have the similar object in this radius. And we check the second radius, the third one radius, 0.5, and we try to pairs of attributes on the green. We have found some objects indiscernible in this degree, but this object have another decision, so it's inconsistency, and we stop our granulation, and the final radius is 0.75. So we expected in this radius 0.75, we expected object indiscernible with central object, but without conflicting in the knowledge we have. So maybe it's not perfect example, but perfect is the block of objects which are indiscernible but in the same class. And the basic idea on the real decision system, that this kind of blocks are created, and it's good representation of decision systems. And so on. The set of granules is as follows. This is the granules computed on the universe of objects. And now we have to find the coverage of the decision systems. And we can use any technique. As you can see, this is random choice. It consists like that. We choose randomly the granules, and we check if these granules cover the whole set of objects from 1 to 10. These black granules cover the decision systems, and we can create from each of these granules by majority voting just major value for each attribute we select, and we obtain the final decision systems, which look like this. This is our granular decision system, smaller one, homogeneous granular system. And for this particular system, the diversity consists of choosing random granules. So you can by random choice you can obtain the set of systems, but these systems we expect that the systems contain some internal knowledge inside. And here we are. Here we have some random forest. Of course, we know the random forest. The basic idea is to use some random trees on data, and we combine random forest with granular technique. Using in experiments following systems: Australian credit, PIMA, IRIS, and heart disease. We try the effectiveness of random forest, and the options we used here are as follows. Nil case, we use just random forest classification on a trying decision system in the cross-validation model. And in case 1, we granulated using homogeneous granulation. Of course, it's obvious that we have granulated some decision system in cross-validation. Some trying decision system are granulated, and we use them in the process of random forest classification. And in last step, we have the first run on random forest on TRN, and in order to choose some least important attributes, and homogeneous granulation after this operation on selected attributes. And we secondly run the random forest. So some hybrid technique, Krzysztof checked in experimental works this option 2. Maybe the results are not spectacular. I show the results. This is some basic information about the accuracy for IRIS. As you can see, this is some statistical representation, but here is the most important. Not bad. Here we have the results for IRIS. And the most important thing is here is mean value. As you can see, the nil case is 95, case 1 is 93, case 2 is 93. Then approximation of decision systems is in range of 40%. We have about 40% flowering of objects in the decision system, and the lowering of accuracy is here about 2% for RVs. Not spectacular, but promising. It works with the lower decision systems. Here we have the results for Australian credit, and the mean value is here. Nil case is also the best, but it's actually in the range of standard deviation. Australian in case 1, 84.6%, in case 2, 84.8%. And here you are the PIMA, Indian diabetes. Also the result is good. The mean value is here, and the case 1 and 2 is similar to nil case with this proper approximation. Here are the approximation, yes, this mean size of TRN. Mean size because we use cross-validation, so it's mean size of training decision system. Original system, training decision system, and it works with the same way, so random forest works. And the last system is heart disease. Heart disease in nil case is 80%, in case of granulated data sets based on random forest, and these two options is 77%. And as you can see, this is rather spectacular lowering of decision system size, training decision system size from 242 objects to 90 objects in case 1 and to 106 objects. Average number of training objects in the system. And this is the summary of results. And I would like to conclude the work. As we can see, the random forest work not bad, maybe not spectacular, our best method, but is the next step to check some options to use the homogeneous granulation, and we hope then this hybridization with random forest we developed on a better level and using some other researchers. And our future work is to use homogeneous granulation in the process of feature extraction in neural networks. So you have neural networks, you have the convolution and pooling, and we are thinking about the granulation. We have the set of techniques to use in the process of pooling or convolution. And it's actually the end of story. I'm waiting for questions. Thank you very much.
Okay, thank you.
Thank you for presentation, Piotr. Do we have any questions from Kaunas?
Okay, do we have questions? Yes, we have one question.
One question, okay.
From Professor Evaldas Vaičiukynas.
Yes, hello, do you hear me?
Hi.
Hello, do you hear me?
Yes, of course, thank you.
Okay. I have a question about,
I can hear you.
I saw the example, how do you measure radius with those categorical attributes, right? In the toy example. They were categorical, but I saw in your experiment...
Yes, of course, it's categorical.
Yeah, but when you use non-categorical, like an iris, for example, case, how do you do this comparison if they are same or not? These data points, if they are same or not?
We are talking about data types in granulation.
Yes, when you use the categorical, it's pretty clear. If it's the same category...
Oh, of course. I will
how do you
explain.
do that with integers?
Of course, in the case of granulation process, it's to avoid the problem of mixture of attributes. We check the system which works in categorical form and in numerical form. So, for instance, Australian credit, it unexpectedly to me works very well with when we use this mixture of attributes. Also numbers, used as symbols. It worked very well. Try to do on Australian, for instance, to create dummy variables from symbolic attributes, and you obtain worse classification accuracy than you use on these attributes as symbolic, the whole set. But of course, we are prepared to use our techniques, and in previous research, we have used some epsilon ratio. This is indiscernibility of attributes, and we use also numerical attributes in the process of granulation. It's really easy, and just you having some values, you put, for instance, the epsilon 0.01, and using some measure, some distance between attributes, you can say that the attributes are indiscernible, and it can be used in granulation process. So not problem for us to use some mixture of attributes. And here just as I guess the attributes were used as symbols here, categorical.
So thank you.
I hope it's
yes,
enough.
thank you for answer. So Martin?
I think the presentation is good when there is a progress. So there is a good result with the progress to future. So I don't know. I don't have any questions now. I think problems are solved. So thank you so much for presentation, for being with us, Piotr. Please also be there next year, hopefully in reality, not virtuality.
Yes, I'm sure.
So
I'm sure, Marcin. I'm sure, Marcin and Professor Łopata, thank you very much. It's also a great pleasure to be a part of conference. You are really fantastic. I like Lithuania, and we are waiting to see you in Lithuania next year.
Yeah, thank you very much.
Thank you very much.
You are always welcome in Lithuania. Okay, so now we will have on-site presenter and on-site presentation. So, hello. Hello, I'm Nerijus Šatkauskas, and I am a co-author of the publication, which is Orchestration Security Challenges in the Fog Computing, and the other authors are Mr. Algimantas Venčkauskas and Mr. Nerijus Morkevičius. So the introduction. For the introduction, I would like to add that fog computing, as it is identified, it is a new paradigm which is meant to solve certain issues that are faced by contemporary Internet of Things, or IoT, and the issues are like widespread geographical distribution and mobility, multiple nodes, heterogeneity of hardware, and communication technologies. Meanwhile, the orchestration solutions, or the orchestrator itself, which is made available in these fog computing systems, enable different devices which are connected to the network to be controlled. So, in order to generalize it, this is a review paper yet, and first it identifies fog computing security threats as this is the environment where an orchestrator will operate, and we also did a review of some orchestration solutions, of potential solutions, and in order to identify the orchestration challenges, over 150 papers were reviewed.
So, in order to make it clear, what is a fog computing paradigm? It is actually a three-layered structure, and the bottom layer is the most diverse one, and it is made of different smart devices, sensors, actuators, different machines, mobile devices, edge devices, and so on. Meanwhile, fog layer, the middle layer, acts like access points, firewalls, routers, cloudlets, switches, and so on. And the top layer is meant for cloud, and it is actually a large-scale data center which is used for powerful calculations. So going up a vertical layer, we get more computing power, data longevity, data storage, reliability, and unfortunately latency, as RT devices and nodes are meant for some small, very small calculations. They often save the battery power, so they just send the signals to the fog layer, which decides whether the calculations, more sophisticated calculations, should be done locally or whether it should be sent to the cloud for even better results. And going vertically down, we get the location awareness, we get the mobility support, geographical distribution, we get responsiveness, and unfortunately delay as well. So, data management in the fog computing is, as you can see, is also mainly split into three layers, and the first layer is a device layer, and it is designed for data acquisition. So in other words, these devices collect data, and they send that data to the fog layer, and that device layer also executes the commands that are being given by the fog layer or even cloud layer. So the middle layer offers a lightweight processing or temporary data storage. So to make it more specific, it includes data aggregation, data compression, data decompression, data inscription, description, and so on. So, but if we want to get more detailed reports or store data permanently, we should direct it to the cloud layer. Fog computing itself, as it was identified by the Open Fog Consortium, has certain threats, and these threats can be split or divided into certain categories like confidentiality, integrity, authentication, availability, and privacy. What concerns attack venue, so these threats can also be divided based on whether they are made by insiders or whether it is hardware attacks or software attacks or network attacks, and so on. And all these categories have their typical threats. In order to get a general idea of what is an orchestrator in a fog computing, I have added one of potential solutions, and this solution was proposed by Mr. Brito and others.
So he suggested that fog orchestration agent should be added to each fog computing node in order to make it responsible for communication, for monitoring of resources, for efficient resource management, for security or quality assurance, and so on. So in order to be more specific, what was how that review process was made in order to identify fog orchestration challenges as I worked my way through. I have used certain keywords, and I have also used Google Scholar as an academic search engine, and these keywords returned over 1,000 of results, and I have checked over 150 papers looking for relevant orchestration challenges or threats in order to make sure that these papers discuss or analyze the ideas that I need to include. So based on this, I have picked 20 papers which provide enough of details about potential challenges that can be faced by any orchestration solution. So the way I worked, it looks like that. These are the papers on the left, and these are the features on the right, and I have summed them up to make to calculate the percentage. So in order to summarize that the review, it is possible to state that security and privacy is most commonly mentioned in the papers as the most common concern in the Internet of Things, and namely for the fog computing orchestrators. These papers also identify dynamics or mobility as a big issue which needs to be addressed, and as well as scalability or complexity, and so on. We have also concluded certain restrictions in order to better develop fog computing orchestrators in the future, and these restrictions should be considered in order to avoid certain problems. So first of all, security level requirements. It means that there are devices that may collect data of different importance, and so fog computing solutions should apply measures of a different level when that data is transferred, stored, or processed. There are also fog computing node physical constraints, and it means that some nodes might not be capable enough or might not have enough physical power to use different security or communication protocols to make that communication safe enough. There are also communication bandwidth requirements. It means that some fog computing nodes may need the continuous data streaming, and meanwhile other fog computing nodes may need only one-time signal transmission. So that bandwidth should be considered in order to make it optimal enough. There are also communication protocol requirements, and as some devices may need one-way broadcasting, and well, other devices may require strict two-way communication with acknowledgements, or some devices may transmit signals at a shorter range. Meanwhile, the other end node devices may require long-range transmission of their signals. So, as it is a review paper, yet we consider further work, and one of the options of our further work could include using the use of topologies in order to make a list of security features, and these topologies, as we have considered, should be converted to Java classes, and finally we might use SATIS matrix for analytical hierarchy process calculations. That means that we might use that matrix to calculate which of the end nodes, among other nodes, use the resources in a more optimal way, or which of them operates in the most secure way based on the environment requirements. In order to conclude this publication, we have reviewed over 150 papers looking for orchestration challenges. And these challenges were classified in order to detect the most relevant ones, and the results suggest that security and privacy, or dynamics and mobility, and even scalability or complexity, and a few more other issues are very relevant ones, and further work should be done in order to explore these issues. And this is a paper. This paper is a part of Horizons program. So, thank you for your attention.
Thank you very much. Questions? Martin, we do not have questions here.
One question.
We have question, yes, from
yes. I have one question.
Okay.
Of course, it's not the topic of my research. I don't know anything about it, but I have a question about the reverse engineering attacks. Have you ever think or try to research how the reverse engineering attacks can be used on this kind of systems? Because you have there some IoT system, and it's obvious thing that the hackers can try to disturb this kind of system.
Yes, you are right. It is also an option.
In case you have some information.
It is, you are right, and it is an option that a reverse engineering can be done in order to attack these end devices. As in this review paper, as far as I've done that review, looking for the most common issues that the IoT faces, I have not identified reverse engineering as the most common one or the most significant one. So yes, I do agree that it is possible. However, other researchers do not specify it as the issue of the priority one, which should be addressed as soon as possible.
Thank you very much. It's the future of hacking, the reverse engineering.
Sure,
Not knowing
sure,
anything about the system, you can use found some equipment in the system in IoT or. Thank you very much.
Thank you.
Okay, so if we have no further questions, let's move to the next presentation. This time is a novel edge detection operator for identifying buildings in augmented reality applications. And I see we have Cyprian online. So hello, please start with the presentation. Nice to meet you.
Hello, nice to meet you, and thank you for this opportunity. Let me share my screen. Can you see my screen?
Yes, all is good.
Okay, so thank you. Today I'm going to present our paper, a novel edge detection operator for identifying buildings in augmented reality application. First, I would like to tell the motivation how it starts. It started because of one of our projects. We have a university, Spotlight Heritage, where we try to use augmented reality and in the environment we have to highlight buildings that have historical meaning. And by doing so, we saw that we could improve our environment, our algorithm that does the actual detection. So doing so, we tried to find a better suited algorithm that helps us to find more features and contours of the building, but not to create a bigger amount of processing. So we looked naturally to the orthogonal first order derivatives, so the edge detection filters, and we tried to find a solution to have more weight or have a bigger importance in the pixels that are perpendicular, so in 0 and 90 degrees on the gradient. So by doing so, we tried to experiment with different and research different weight matrices that are behind the operators, and we stopped upon these two variants. We tried them both to see which actually obtain better results. So the first one is actually we are inverting the distance, the Euclidean distance between the pixels, and in the other one we actually take the maximum distance in the area. So we obtain, actually, as you can see, when we are talking about a 3x3 kernel, we obtain the same weight matrix. Further on, we use the local polynomial approximation that was presented earlier by Haralik, and we try to obtain the actual gradients oh, I have a typo, sorry, on both directions. So we obtain the 3x3 filters for variant A of the weight matrix and the 5x5 gradients. We looked upon both of them because we consider that when talking about edge detection in buildings, it's important to consider a higher or a more bigger area. So we looked upon the 5-to-5 kernels too, or operators. In the second variant we obtained the same 3x3 kernel operator, but when we go to 5x5, we obtained smoother matrix, we could say. Okay, to better understand our results, we actually then compared our operator or our proposed operators with classical ones. So we took the most popular one we saw. We took Sobel, Previt, and Char. The kernels are presented here. And we took the 3x3 kernels and the 5x5 ones. Okay, so here we present the results we obtain with our filters. As you can see, just looking at the magnitude, we don't see very much the differences. We can clearly see that the results are similar or what we usually see when we apply Sobel. To better understand our results, we used a more advanced edge detection algorithm like Kenny. We used a variation of it that takes in consideration the Otsu transformation for the calculation of the thresholds. This actually improved the edge tracking hysteresis because it takes in consideration the difference between the foreground and the background. And we presented the actual formulas we used for calculating the lower and the higher threshold. Okay, as we can see, when we applied Kenny, the differences are more visible. As we can see, in our case, the proposed 3x3 filter obtains, we consider a better balance between edges that represent the contour or the edge of the building and details on the facade of the buildings. This was very important to us. Comparing to other algorithms, we see a better balance. Unfortunately, when we went to the 5x5 operators, we didn't obtain the results we hope. So we hope that if we take in consideration a bigger zone, we will obtain bigger and longer edges. Actually, one of the desired outputs was to consider to find longer edges, as we could then cluster them afterwards. Okay, so first one, we wanted to see exactly the differences, and as we can see, the amount of edge pixels that were found by Sobel and not found by our algorithm, our operator are pretty narrow. But considering what edges we found and Sobel didn't find, we can clearly see that we found longer edges and more edge points, and not introduce a lot of noise. So then we moved forward and took 30 images from the Spotlight Heritage Project, all being buildings. You can find them in the paper in Appendix A. And then we compared the results using Sobel, using Sobel 3x3 filter, and using our proposed 3x3 filter. As you can see, in all the cases, we managed to find more edge points and longer edge points than the Sobel one. Okay, conclusion. So this was actually the first step for improving the algorithm in our project. It has improved the detection. Like we said, we aimed to find a first order operator that finds more edges that are perpendicular, and we did find more edges that are perpendicular. And in the future, we are continuing this path and trying to see statistically on a more bigger data set to see if this theory holds. Our guess is it does hold. And we are analyzing other algorithms that this operator can be used on. Like I said, being a mobile application, we are avoiding very complex edge detection algorithms that have, for example, machine learning in them or other aspects that have a high computational need. So here are the references, and thank you. Sorry if I present very quickly. This is my shortcoming.
Okay.
Thank you so much.
Questions? So we do not have questions on site, Martin?
I don't think the presentation was clear also with the starting results. So it seems that Kani filter will be growing with the new algorithm in the future. And I just want to ask some idea for other shapes, not only buildings. Would it work the same with cars or rounded shapes, things like that?
Actually, my guess is it wouldn't work with any shape because the fact that I will go back a bit, the fact that we have a bigger weight on the perpendicular gradient, here, it will actually improve the detection of edge points that have the directional on 0 or 90 degrees. It will not be so good when we talk about points or edges that have a diagonal direction. So my guess it will be better with regular shapes than with non-regular shapes.
Any other questions?
I'm just curious. May I have a question?
Please.
Sure.
I have a question about the possible application in convolutional neural networks. Yes, you have some detector, a feature extractor, and have you ever tried to use this feature extractor in the process of convolution in CNN or not?
Actually, no, because we just limited ourselves to applications that we can apply on mobile devices. We are looking right now another other thread on the mobile net. We have read that it could be used on mobile applications, but usually from what I saw, when we are talking about CNNs, we are talking about auto-generated trained kernels. So we can hard code this one, but I think from training it will result a better one. At least this is my understanding. I'm not an expert in that area, but
it's possibly applied, and I'm just curious how it works in comparison with some other similar feature extractors. Just comment. Thank you very much.
Oh yeah, but then now I understand better. Yeah, actually, we will. This is the future work. We will try to do a statistical comparison between it and other first-order derivatives on a more common data set. Right now we just applied it on our data set because that was our need. But in future we will try to do it on the Berkeley one or New York data set.
Thank you. Congratulations. Good work.
Thank you.
Okay, so if we have no more questions, we should move to another presentation. Thank you, Cyprian. And
thank you.
Now we have the fourth presentation, military vehicle recognition with different image machine learning techniques. I think Daniel Gendre is with us. So Daniel, please do presentation.
Hello. Yes, I am here with you. Hopefully you can hear me and you can see me.
Yes, super. It works. Yes. Share the screen for presentation.
Okay, perfect. Then I can continue to share the screen. And we can continue. We'll start on the presentation. Okay, just a quick question. Everyone can see the presentation, right?
I think it's okay.
Perfect. Well, good afternoon. My name is Daniel Legendre, and in collaboration with the Suomen puolustusvoimat, that is the Finnish army, we made a paper about machine learning titled Autonomous Military Vehicle Recognition with different image machine learning techniques using social media images. First, we're going to talk about how the paper is laid out. We've defined what is our aim, how do we use neural networks and machine learning for a purpose, what kind of image data set we have available, because since there are military terms, then there is a lot of confidentiality involved. Also, we're going to talk about how do we overcome certain limitations that we have with the image data sets with data augmentation. We apply transfer learning with some big already made machine learning architectures. We compare these results with our own architecture design for machine learning. And finally, we make some clarifications on different images to see how well and how bad are our predictions. And we make recommendations on how to improve the current systems. So what are the main challenges? Main challenges is that monitoring social media content demands extensive manual labor, and there is not sufficient military trained personnel to monitor all possible social media news feeds and video cameras around the globe. This not only includes social media images online, but also real life camera recordings on different kind of equipment. What do we want to do? We want to use openly available resources to train neural network systems to recognize military vehicles. It doesn't have to be limited to military vehicles, but most into the area of military terms. And this has to be located within social media photographs or not monetary vigilance cameras. This is, in principle, an autonomous system that can scan the web and gives alerts where a military equipment is located around the globe. And this will, in principle, recognize two things. First, the image source and locations, their GPS coordinates, and B, the type of military equipment. Of course, if this information is available online. Now we're going to make a very brief explanations on the neural networks that we're using. Neural networks are a mathematical model that resemble to an actual neuron, and this structure can store numbers, image, pictures, or vectors. If we combine them, we can make simple systems that make simple decision makings, for example, on and off switch decision. Further on, this can be extrapolated with systems, with complex systems of more than 100 neurons and more than one hidden layers to make more versatile decision-making programs. This is what we call deep learning. These neural systems must be trained to learn the right type of different parts of our equipment that we want to recognize. And normally this requires a very large source of labeled images, normally in the order of magnitude of plus 10,000. Normally, more neurons and more layers just implies a more versatile decision-making software, but if this is more complex, doesn't necessarily mean that your system is better suitable for your particular recognition task. So bigger is not always better in neural networks. Now, what is the basic structure that we're using? We have an input layer where we input the data, in this particular case, the image. Then we have hidden layers that in our case are convolutional and linear layers. And these include the feature classification nodes where the actual learning happens and the system is capable to recognize different elements through different filter operations. And finally, we have an output layer that in our particular research is based in a softmax layer that gives a percentage of how accurate is this image to regarding classification that we put. Normally, a neural network can be optimized in terms of the number of neurons, the types of neurons, the types of layers, the numbers of layers, the different accuracy metrics, and the different loss functions that we use to define how well or how good is our neural network. Then we're going to start to explain where do we obtain our data. For training neural networks, we need a large amount of data. And unfortunately, this is not openly available for military resources. But there are different ways that we can obtain military data from online parts. For example, this particular data were obtaining for different conflicts, particularly in Eastern Ukraine, and other kinds of wars that are available online. They were obtained from different sources, from YouTube, from Flickr, and from other websites, and within different types of military equipment. In the next slides, we're going to see the types of military models that we have. These are different types of tanks that they are available and used by different armies around the world. And these are the number of images that we have of each of them. If you see, the number of images are like in the low end for military, for machine learning recognition, but there are ways that we can overcome these limitations. Also, we don't limit our research only to classify a type of tank, but also in which condition is this tank. If this tank is covered by a smoke layer, is it's in an active attack by firing, or if it's in some kind of camouflage mode. How do we do the training with data augmentation? First, we need to separate our data between our training set and a validation set. The validation data is normally unaltered, and that's something that we don't touch, and we only use to see how good is recognition. Within the training set, we create artificial images from the images that we have to make our system to recognize better these features. How the augmentation works in this particular paper? Well, our solution to satisfy the requirements of thousands of images per class is artificial image creations. With an original image, we can apply random transformations. We can flip it, we can zoom it, we can rotate it, we can apply small transformations into it, and further on storage them into the different categories that it has. So that way, from an image, we can have subsequent child images that will increase our amount of data available for training. This normally doesn't work that well for, let's say, biological systems, such as recognition of humans, of animals, but it works very well for recognitions of machinery, since all the machineries are normally very similar among each other. First, we're gonna try to use something called transfer learning. We're gonna use a very big, already pre-trained learning models and adapt it to our system. The main idea of transfer learning is that we use a very known neural network that was defined for a different task, and we simply cut the top of this neural network and we adapt it to our own design task, retrain it, and be able to use the previous recognition parts of that neural network into our own new recognition system. So which large pre-trained neural networks we use? We use ResNet, that stands for Deep Residual Learning for Image Recognition. This was developed by Microsoft. And Exception, that stands up for Deep Learning with Bitwise Separable Convolutions. And these are very large networks that have been trained in a system called ImageNet, that it is the largest database of image in the world and is completely free available, and contains millions of images within 1,000 categories between cars, humans, pencils, computers, and everything that you can think of. It is classified already in ImageNet. Now, these two very large neural networks, ResNet and Exception, they are normally too large to be trained completely by normal resources. Actually, these were developed by the teams of Microsoft and Google. So these are the biggest neural networks that are available. What do we do with this? We take advantage of the previous architectures and designs that they have. We use their own neural network, we cut the top part, and we put our own top of last hidden and output layers designed for our particular military tasks. Then we join these two, and we finally train this new hybrid neural network with the image dataset that we have. And that way we can adapt already known neural network that has been used for a civil purpose into something that can be used for a military recognition purpose. We continue and we take this step further. We can say that we don't only train the top part that we add to the neural network, but we expand within a variable section of how far do we go into the original neural network to be trained. For example, these neurons are very large and it's impossible to train them completely, but we can decide, for example, to train only the last layer or the last 5 layers, 10 layers, 20 layers, and so on. And we can determine how far do we have to go until the beginning of the network, until our new training process has been adapted to the new classification that we want to give it. So how do we do it? We make a code using TensorFlow and Keras that allow us to select how many layers do we need to train of this new hybrid neural network. And in function of that, we select our optimal configuration, taking into account the neural network that has the highest validation accuracy and the lowest validation loss of the system. For example, this is the case for ResNet, and for this particular case, we can see that the new trained neural network for military recognition purposes has already accuracy of plus 94%, which is really good in terms of recognition for images. And we did the same thing with the other large neural network called exception. It turns out that this neural network was not possible to be trained with reasonable validation accuracy values. Actually, the validation accuracy values are below 30%. And we can see that this is a very overfitted network, which means that this network is way too large to be only trained with the last 20 layers. So which for this, there are needed bigger computational resources to even train it in a larger scale. So how do we test how well do we did? Well, we separate our training into different classes. Within the classes, we separate different types of military equipment. In this case, were tanks, for example, T-72 tank versus a BMP tank and an image class of images called Other, which includes mainly civilian vehicles. And within this, we can notice that ResNet, this particular neural network, when it has been trained to the military vehicle dataset, it has high validation values of plus 80%, which the highest one being 95%. And in contrast, training the neural network exception gives very poor values, except one training dataset that has 64% of accuracy. Now we want to see if including and injecting artificial images to this system will actually be beneficial. So we apply a different loop and we program a different part that frozen all the numerical scheme of the training of the neural networks and adds a number of augmented images per training batch. So we start with the 0 number of augmented images, which is the original case that we train, which has a 95% accuracy. And we increase the number of images to see if this improves or doesn't improve the system. For the particular case of BMP, Leopard, and Sisu, and other, which are different types of tanks, we can see that for the case of ResNet, that it was a very well-trained neural network that has a high accuracy. It actually doesn't have an effect. And for the case of the exception neural network, which was an overfitted neural network that has a lot of room for improvement, actually it didn't improve anything. So from this, we can conclude that a very large pre-made neural network actually doesn't benefit too much from image augmentation because it has already very refined feature recognition purposes, very refined recognition algorithms and filters that they can very difficult be further on refined. But for example, if we create our own architecture and we make a small neural network that is in principle 100 times smaller and takes significantly less resources to train it, we can aim to the same level of accuracy, which a much smaller system and only using image augmentation. For example, we create our own architecture based on variable optimized neural network structure that includes convolutional layers, dense layers, and output layers. With this, we make a variable the number of layers that we use and the number of neurons that we use, and we use a plus 5,000 augmented images to see how well we can get making our own designs versus large made pre-designs. With this, we make our variable architecture training and we make the same kind of decisions. We take the best neural network configuration in terms of validation accuracy that has the least loss of the system, which is the ideal what you want to get with a neural network training. And we allow the system to have different architecture. Within this, we choose the best architecture for every system, and we can obtain, for example, that for our system, we have several variables, the types of layers, numbers of layers, and the numbers of neurons per layers. Within this, we could see that for the same classes that we have in the previous case, if we train our neural networks only with the original data set that we have this first column of validation accuracy results. But if we increase the number of images, we can see that the validation accuracy increased in an average of 10% within a maximum of 20% in certain cases. So that means that using a neural network that is 10 times, 20 times smaller, with data augmentation, we can get as good results as using a very large pre-trained neural network within a validation results of 90% or 80%, which are very good for recognition purposes. Now, how does this look in terms of a heat map? For example, if we use the first system and we find an optimal architecture of neural network, we can see that an original system that can recognize images with a 75% of accuracy can increase until 81% only by adding artificial images into the system. And this is for a neural network that is already good, can be improved a little bit into the plus 80% area. And for example, a neural network that has an accuracy of 62 can be improved until a level of 83%. So that means that the more room for improvement, the more improvement the artificial image dataset we give into a training algorithm for system. So of course, this also means that there is an optimal number of augmented images that we can track and optimize on each of the training schemes that we use for our neural networks. Finally, we show some results on the types of images that, for example, we can find in different cameras. For example, in the first one, this is a T-72 tank, and our neural network exception was able to recognize it quite well. ResNet made a mistake. It confused it by a BMP type of tank. And finally, our own neural network was able to recognize it very well. For example, in terms of BMP, all the neural networks were able to recognize it very well. Notice that our own image augmented neural network was also able to recognize it very well. Of course, none of the neural networks are perfect. There are sometimes, for example, in this vehicle that even if it looks green and it looks quite a military vehicle, as humans, we can see that this doesn't represent a tank, but our own neural network makes a mistake and thinks that it is a tank, which it enters into the margin of error that our system have. Further on, we can test with other types of vehicles. For example, we have a tank that is a Leopard 2A4, that this tank is very characteristic to have a very large cannon, and a CB1930 that it is characteristic to have a rather small cannon. And from this, we can see that, for example, all the neural networks are capable to recognize very well the Leopards and very well the CB1930 because they are very different. And on the other types of images, some neural networks make mistakes, but they are still within the recognition ranges. For example, ResNet and our own neural network system have accuracy results of plus 85% in these areas. So they are very good for recognizing things on real life applications. The same goes for the camouflage versus the non-camouflage tanks. Of course, in certain positions, the color of the tank, because it's similar to the color of the environment, it might be confused with the camouflage tanks, but in most of the cases, it works very well. And for this particular neural network, it had 3 convolutional layers, 64 neurons, 1 dense layers, and plus 4,000 artificial images. Finally, if we go to the part of the situational environment of the tanks, we can see that separating a smoke tank versus a fire tank might be very easy because mainly is based of color. For example, if you see a red or an orange color, you might know that the tank is firing. And this is the reason why our training gives such good results for this particular part, that they are normally plus 85, 90% of accuracy. In some cases, even higher. Now, the thing with this neural network that works very well for recognizing a smoke tank and a fire tank is that sometimes it can make mistakes. In terms that, for example, if we use a red car that has a flame color pattern, most of our neural networks will recognize as a firing tank, when in reality, what we have is just a civilian car that has a different paint job. So for this kind of neural network, what we recommend will be using a sequential type of recognition. Use first another kind of neural network that is able to recognize that there is a tank. Then another type of neural network that is able to recognize what type of tank it is. And finally, using this neural network to recognize if this tank has been firing or not. Because using this neural network as a first recognition mechanism will give you a lot of errors So everything that is red or has a flaming patterns will be recognized as a firing attack tank, which is not the idea. Even if numerically this type of recognition gives the highest accuracy and validation and all the numbers are over the chart, we should be careful on how to use the recognitions on this part. Further on, we're going to talk on how can we make these results better. Well, it turns out that clipping, scaling, rotating, and flipping doesn't necessarily increase performance on very large neural networks, but it certainly helps into the performance of small neural networks. So we can use 3D models on the same scale as real life vehicles, using, for example, Google Earth and different CAD models that we have for different tanks into making more robust set of artificial images. Within this, we can have different angles and different tank models. For example, we can include tanks that they have been not sufficiently recorded in outside living conditions, but they exist. And we can add for this recognitions of vehicles at different angles, positions in different locations around the globe, even more diverse set of military equipment, that we don't have to limit these to tanks. We can go to airplanes, helicopters, or even military personnel. And more on that, we will have a machine learning generating training set that is way larger than the human generating training set, since there is a lot of confidential issues within different governments that doesn't allow the recording of different military equipment. Now, we made an example in a paper. For example, there is an area of Helsinki called Senatintori, which is kind of like the main church of Helsinki. We use a wireframe drawing of a tank. We put the skin on the tank. Further on, we just copy paste it on top of an image that we have of Helsinki. Now, probably this seems very simplistic, but we can actually automatize this into making images of different parts of the globe. So how do we do this? We take images of realistic scenarios within the different GPS coordinates of an area. For example, this is the particular coordinates of an area in Helsinki. We extract the 360-degree image from a street view from Google. We make a sphere globe mapping and a level detection of this image. And within this, we can obtain an image like this, that it gives us a tank that particularly can have any kind of orientation, and it is kind of like put and labeled as in a similar size of different vehicles that are around. Now, what do we learn from our research? We learn first that deep learning libraries and architectures that are pre-trained, they are very useful for military applications. So that means that even if we can recognize every kind of things, with civilian purposes, we can use these neural networks and adapt it to the military data sets to be able to recognize military equipment, and that will allow us to have an automatical recognition system that can give us alerts if, for example, a new armed conflict arise in certain parts of the world. This, of course, doesn't work perfectly in optimal conditions, such as half-covered vehicles, very dark scenarios. But even if data augmentation cannot create images that we don't have, using pseudo placement of 3D tanks on real scenarios could actually narrow the gaps of the type of images that we don't have. For example, we could say that we don't have that many images that are like in very dark scenarios or in snow or in desert kind of like ambience, but we can make them using the different like 3D images or 360 degrees photographs from Google Earth. Further on, transferring learning from neural networks doesn't really benefit from image augmentations, because these neural networks are already very accurate and very refined. But if we build our own neural networks, they actually benefit a lot in terms of accuracy by image augmentations, with values of plus 10% of increase into the refinement of the accuracy of these systems. This is with the aim to develop an autonomous model that is able to track military vehicles, not only in social media, but also in different cameras, drones, and other not tripulated vehicles around the world. So that means that we will be able to recognize different types of military equipment, regardless if there is a human or not watching through the cameras. Finally, I would like to thank everyone for the time. The authors of this paper wish to acknowledge the Center of Computer Science of Finland for the computational resource for this paper. So thank you for your time and attention, and I'm hearing any questions or comments that you might have.
Okay, do we have any questions from participants?
Yes, I have one question.
Yes.
Daniel, what about the pre-processing of images? Have you tried some kind of thresholding or binarization of images before using in your models? And you have some experimental results in this case by binarization and thresholding. Have you tried it?
Can you repeat the questions? I kind of lost the audio for a second.
Okay, thank you very much. Can you hear me?
Yes, I can hear you now.
I'm just curious if thresholding or binarization of images can help in your model and have some influence on accuracy, on efficiency.
Well, I mean, we didn't test it, but I mean, in principle, yes, we can apply different filters of the image just to make kind of like the edges of certain parts like even sharper. But the difference with apply a different image, a different filters, is that we will need to have a type of filter that is actually helpful for this purpose. And it will be an interesting part to test. I will think that in principle, yes, it will improve the efficiency.
Thank you very much. Another question, maybe a little bit,
but we will have to test
ignorance from my side. What kind of activation functions you use in the layers of your network? Of course, we know about the softmax there, but what kind of functions were used?
Well, for example, mostly are rectify linear functions between the different layers, but we use two types of layers. If we can see in this particular slide where I show the types of layers that we use for their own, here it is. For our own architecture design, we use a convolutional and dense layers. It's a very simple recognition system that has been used, but for example, the ResNet exception, they use different types of algorithms. For example, ResNet is based on residual neural networks, and exception is based on convolutional neural networks.
I'm just curious if the leaking ReLU if works better in this case, because you have ReLU and leaking ReLU. In some cases, leaking ReLU works better in these kind of systems.
Well, it will be a matter of
leaking also.
No, we only use ReLU. I mean, like it would be interesting to check leaking ReLU. Perhaps might increase the results, but this is a matter of like handling the amount of data that we have, and we rather for these particular terms just stick with ReLU and with what we know it works.
And the last question, I'm just curious, how you measure the effectiveness in this network? Have you used cross-validation 5, for instance, and have some mean value here?
Well, we don't have enough data to use cross-validation. So that's why we use the data augmentation part. And the thing is that we notice if we use, for example, if we divide the data, like in this slide, if we divide the data already into a validation set and a training set and expand this training set, if we want to use a cross-validation within this part, then we cannot really use a cross-validation because this cross-validation which will already include certain images that were already used for augmentation. So we'll include some kind of contamination of your data sets. So we don't have enough data to make a cross-validation in this part because we use all the data to be used in validation and training. But for example, I can tell you that most of the data was rather homogeneous, like the kind of like images that you could see a human could recognize that most of them, they were a tank or there was like a different kind of tanks. And the thing I did like different runs for the systems, and the order of magnitude of the accuracy were within 1 or 2%. And I can tell you that it works very well for only for military, like not military equipment, but vehicles and machinery. And it will not work well for animals or human faces, for example.
I think it's possible to use not maybe the pure cross-validation, but for instance, Monte Carlo cross-validation. You have some set, maybe small number of, and Monte cross-validation is simple. Yes, you can use the same data many times, but in a different random split of images. And
that's actually very
but
true.
It doesn't matter.
It is very true. I mean,
Yes,
like a Monte Carlo might allow us to circumvent the part of like the contamination part, and I think it's something that we could take into account for future research. So it's a good idea.
Thank you, Daniel. Great research and a lot of work to do to prepare these results. Thank you very much.
Thank you very much.
Okay, thank you for great discussion. Do we have any questions from audience?
Martin, I think that we are short in time, so we do not have.
Okay, so we're just moving to next presentation. Runtime class generation algorithm for decomposition of homogeneous classes, and Dimitro is with us, so please do the presentation.
Hello, everyone. I hope everyone can see and hear me. So I will share my screen. So is it my screen visible?
Yes.
Yes, please.
Okay. My name is Dmitro Terletsky. I'm from Taras Shevchenko National University of Kiev, from Ukraine, and let me represent some results of my research called runtime class generation, algorithm for decomposition of homogeneous classes. Here is the short outline of my presentation, and let us start. As you know, adaptability is the one of the most important features for intelligent systems, because such systems can react on some changes in the working environment, and this is one of feature of intelligence for the systems. So, for this purpose, intelligent systems should be able to change itself in some cases. And if we talk more precisely, it means change their own program codes. For this, intelligent systems should be equipped with appropriate mechanisms, which will allow the system to modify itself during the runtime. How it is possible? There is some approach like runtime code generation, and the main idea is to produce new pieces of pieces of codes during the runtime and execute these codes. So in this way, intelligent system can analyze, modify, or extend its own source codes or source codes of other programs during the runtime. And in this way, the system can produce their own reaction of all challenges in the working environment. So also, the system can integrate these new pieces of codes which were generated in the existed code. In this way, they finish its modification. So, as you know, in object-oriented programming as well as in object-oriented knowledge representation, the fundamental concept is a class. So therefore, the task of runtime code generation can be interpreted as more precisely, it means runtime class generation. So, we can achieve this goal using different approaches. One of them is the development and implementation some operations over the classes. and it can be different operations, for example, set theoretical operations adapted to the classes, and other approach is the decomposition operation over the classes. This is actually a topic of my current research. So let us briefly discuss what does it mean, decomposition of a class. It means the splitting into smaller or smallest parts, or other words, subclasses. And there are two kinds of decompositions. Decomposition. First of them is the full decomposition, when we split the class into all possible semantically correct subclasses. And second kind, when we split the class in all possible semantically correct, but subclasses which have definite cardinality. So, let us discuss briefly the structure of the class within the object-oriented programming. And as you know, there are two main parts of a class. It is structural and behavioral. In structural part, we have static and dynamic properties, and in behavioral part, we have the methods. And similar situation within such object-oriented representation, knowledge representation model as object-oriented dynamic networks. And we have also structural part where we have quantitative and qualitative properties. It's a little bit different than in OOP case, because quantitative properties we use for represent some numeric or symbolic characteristics of essences, and qualitative properties is some kind of predicate which express some qualitative and usually not obvious features of the objects of the class. And finally, the functional part is similar to behavioral part in OOP. We have also methods which can manipulate by properties and other methods and so on. And let us consider some example. Here is the class aggregation in terms of object-oriented dynamic network. It's similar and close to the object-oriented programming notation. And we can see here the class point, which actually defines the point on the plane. And here is two attributes, and for methods. We have also class the triangle, which aggregates the class point and define some abstract model of triangle. And we have three attributes, three quantitative properties as point 1, 2, and 3. It's actually vertices of the triangle. And also we have the set point and get point and set point methods. And we have also method which computes the length of side of the triangle. And we have the method which computes the perimeter of triangle. And also we have the qualitative property is a triangle which actually checks the triangle inequality. So if this inequality true, the property will be true. If not, it will be false. So as you can see from this example, here is some dependencies between the properties and methods. And here we can see that get point and set point methods actually depends on some point, because without point, these methods don't have any sense. So, and also we can see similar dependencies in other parts of the class. And you can see that methods for which computes the length of side use the points. Method for perimeter computation use the get side length method and gets points and so on. And here, and this is the internal dependencies within the classes, within the class triangle. And therefore, using this idea, we propose to define some definition for these kinds of dependencies. And first kind of dependencies we call atoms. So there are two kinds of atoms, structural and functional. Structural atoms, it's actually the attributes which definite independently from other attributes, I mean properties or methods. And if we consider the class triangle, we actually have the set of the such attributes. It's points which are vertices of the triangle P1, P2, and P3. Functional items, it is the methods of a class which are definite with independently from other properties or methods. And in the class triangle, there is no such methods. Therefore, this set is empty. So another kind of internal dependencies we called molecules. It is idea from the chemistry compounds, because internal connection inside the class is very similar and very close conceptually to this idea. So structural molecular, it is the tuple or collection of some other atoms or molecules, smaller molecules, which express some internal dependencies between properties. And here you can see the qualitative property P4. It is, in other words, it is a triangle attribute. It uses points. It uses points 1, point 2, point 3, and methods for getting the point and getting the length of the side of the triangle. So, another kind of molecule is the functional molecule. The idea is the same. However, it is about the methods of a class. And here you can see the corresponding molecules, functional molecules inside the class triangle. Now we can redefine or interpret the notion of the class, homogeneous class, using the structural and functional atoms and molecules, which we discussed previously. So class is the collection of these kind of molecules and atoms. And if we use this idea for description of the class triangle, we will have the following sequence of the atoms and molecules. And actually, we have the constraints, because each atom or each molecule is express some restrictions to the class structure. And in this way, when we want to decompose the class in the smallest subclasses, we need to count these restrictions. Why? Because formally we can decompose the class in many subclasses. However, some of them will be syntactically incorrect, semantically incorrect. What does it mean, semantically incorrect? It means that they will not take in account all these restrictions which were definite in the class which we want to decompose. And we can create by decomposition such classes which are inconsistent or are simply unreal in the domain which we try to model using the class. So therefore we need to take in account these all restrictions. And one of the approach to decompose the class using this idea is the constraint satisfaction problem, or simply CSP. Here is the basic definition, what is the constraint satisfaction problem. And briefly speaking, this is the tuple of three elements, where Y is the sequence of variables, D is the sequence of domains where these variables are definite, and C is the sequence of the constraints, which actually puts some restriction on this set of variables Y. And here is the definition of satisfiability or consistency of the CSP. So CSP is consistent or satisfiable if it has at least one solution which satisfies all constraints from the set of constraints C. So using this idea, we can formulate the class decomposition problem and as the corresponding CSP problem. Here is the definition, and it looks similar. However, there are some important differences. First of them is the domains for each variable is the same domain. If more precisely, this is the set of attributes, properties and methods of the class, and the for each domain D1 and those Dn definite in the same set. Second important thing, it is the set of sequence of the constraints consists of two constraints. First of them guarantees the unique elements will be the part of the solution. Only unique elements, and second constraint provides the creation of possible semantically correct unions of atoms and molecules. What does it mean? It means that this constraint is actually the combinations of atoms and molecules which we described previously, and this constraint checks the satisfiability these restrictions. So here is the assessment, complexity assessment for a class decomposition problem. And what do we have in this table? The first column of the table shows the cardinality of subclasses which we want to obtain by decomposition of the class. Second column expresses the complexity or more precisely number of tuples which we need to consider and check the satisfiability of constraints for finding the solution. And here is the number of subclasses for the class triangle, which we have considered before. And you can see for the cardinality of one, we need to consider simply this, the class. Therefore, we can construct formally 8 subclasses cardinality of one. We can construct 64 subclasses cardinality 2 and so on. And totally for if you want to decompose the class and obtain all possible subclasses of this class in the class triangle, where I want to emphasize only 4 properties and 4 methods, we need to consider 396,744 tuples. It's huge amount for such small class. So what can we do to decrease the complexity? We can consider this problem from another side. In particular, we can consider the class as the set of properties and methods. And we know that the power set of this set will contain actually all possible subclasses from this class or subsets of this set. So in this way, we can build the power set for the class triangle. And we also know that power set is the poset of partially ordered set. Therefore, using union operation on this set, we can consider it as a joint semilattice with the one maximum element, and this element will be actually the class triangle itself. So consequently, using this approach, we can we need to consider only 2 in power of n minus 1 elements. It is the actually cardinality 2 in power of n cardinality of the power set, and minus 1 because we don't need to count the empty set. So in this using this idea, we can consider just 256 subclasses where 254 subclasses are not empty, and it is not the same, not the class itself. So and here is the some numbers how many subclasses of different cardinality we have in this for this class triangle. Again, this is just a formally possible subclasses, and you can see that we can have 8 subclasses cardinality of 1, 28 of 2, and so on. And using this idea, we can reduce the complexity approximately in 9,399 times, because instead of considering all this amount of tuples, we can consider just 254 combinations constructed as the elements of the power set of the class triangle. So, and using this idea, we have developed the algorithm which generates the solutions for this class decomposition problem, and it returns the decomposed classes where cardinality of each classes is are equal to k, where k is the definite cardinality. If we need to use the composition procedure for generation of generation of subclasses of definite cardinality, we use this parameter, and here we generate some combination of zeros and ones, I mean binary numbers, and this way we can create the combination from the set of properties and methods of the class triangle, for example. And here we need to check the satisfiability for each combination, for each constraint from the set of constraints for each combination which we have generated. And also we developed the corresponding procedure for checking of satisfiability of the constraint C for the tuple or subclass of the class T. So, and if we have the satisfiability, then this procedure returns true. If not, it returns false. If this constraint is not applicable to this combination, so the result will be none. So, and here is the some complexity analysis of the developed algorithm. We have this estimation where 2 in power of 1 minus 2, it is a number of combinations from the power set which we need to check, generate, and here is the number of checks which we need to do for checks for each element for these combinations, the satisfiability of all constraints from the set of constraints. We remember that this constraint is represented in terms of class atoms and molecules, which we considered before. And we need to use linear space complexity, linear space memory for temporal storing for each subclass when we generate it. Here's the some results of decomposition for the class triangle. This is the formally possible subclasses of different cardinalities and total amount of all possible subclasses. Here is the correct subclasses which satisfy all constraints, and you can see here is just 49 semantically correct subclasses among 254 formally possible subclasses. And here is the actually subclasses which we obtained after using this algorithm for the class triangle. And you can see them. We also used another data for this algorithm and tested. However, I decided to represent only this example because I used it through the whole presentation. So what is the conclusions? We defined the internal structures of class within the object-oriented programming and object-oriented dynamic network I showed the representation of class in terms of object-oriented dynamic network. However, as you can see, it is simply to transform in terms of object-oriented programming. So we also defined the concepts of atoms and molecules, which represent the internal dependencies between among the properties and methods of the class. And we formulate the class decomposition problem in terms of constraint satisfaction problem. Also, we have optimized the procedure for finding the solution. And we use for this joint semi-lattice interpretation. Also, we developed the algorithm and tested it on different experimental data. And this algorithm can be used in two modes. First mode allows to generate all possible semantically correct subclasses of the class, and second one allows us to generate subclasses of definite cardinality. And the algorithm has exponential time and linear space complexity. And we need also to consider and study this algorithm in more detail in the future and improve it. Because for the classes, we tested it for the classes of cardinality 25, 26, and it was very the difference of time performance was worse than in the case, for example, for a class of 10 or 15 properties or methods. Therefore, we need to find more alternatives to make this procedure faster. So here is some references of our research. Previous results and current state, and you can see and find more details. So thank you very much for your attention, and I'm ready to answer any questions.
Thank you for presentation. Audrus is reminding the time. So I think we just smoothly go to the last presentation. I see that we have Amrani on the phone. Thank you for coming, and also thank you, Dmitro, for being with us. Please also be the next year. I hope in reality. So we're just moving now to the next presentation from Amran. Please do the presentation.
Hello, can you see me?
Yes, all is great. Super.
Yes.
Good afternoon. I'm Rita Amrani, a PhD student in the National School of Applied Science in Morocco, in the Laboratory of Artificial Intelligence, Data Science and Emergent Systems. First of all, I would like to thank all the organizers of this conference and the reviewers that accepted our paper, which gave us the opportunity to participate in this conference and share our research, which topic is Twitter-based classification for personal and non-personal heart disease claims. The presentation will follow this plan. First, I will start by the context, next the introduction. After that, I will describe the proposed approach, then the results, and I will finish by a conclusion and by citing some future works. Nowadays, social media are becoming an inseparable part of human life due to the easy access via smartphones, free access to these idea sharing platforms, and online services provided in various fields. So those who use social media may post their thoughts, feelings, and opinions on almost every aspect of life. Instagram, Facebook, and Twitter are among some of the most popular places online interactions take place. Though Twitter is one of the most researched platforms in regards to academic research. Twitter is a social networking and microblogging service enabling users to read and post short messages called tweets. Twitter messages are limited to 280 characters, and Twitter reports having 316 million monthly active users, and there is 500 million tweets posted per day. And the most important advantage for our research is that Twitter provides a unique big data source for public health researchers because of the real-time nature of the content and the ease in accessing and searching publicly available information. And finally, data from Twitter can be retrieved and at either no cost via the search application interface, because Twitter made samples of tweets available for researchers through direct access to its server. So we can say that Twitter is known to attract more research in comparison to other social media platforms. So that's why we have conducted a systematic literature review, which general problematic is approaches based on classifying tweets in relation to health or detecting diseases from tweets using machine learning methods and big data technologies. And we have searched for English research papers from 2015 to 2019 on the Science Direct and Web of Science databases. And we have included studies that used text data only. So here we have the percentages of the main tasks covered by the included studies. 47% used Twitter for disease surveillance, others used it for the detection of the onset and spread of epidemics, also in the measurements of public concern for diseases, and finally for the study of spatiotemporal evolution of diseases. And now, concerning the machine learning techniques used by the included studies, 35% used SVM, others used multinomial naive Bayes, and also decision trees and random forests, logistic regression, neural networks, k-nearest neighbors, and 5% used the fuzzy algorithms. And since there are very few studies that focused on the prediction or the classification of health status in relation to cardiovascular disease, and which constitutes according to the national in the World Health Organization, the first cause of death in the world. So we have proposed an approach that uses Twitter to classify personal and non-personal heart disease claims expressed by the Twitter users. So this is the architecture of the proposed framework, and I'm going to explain each part. So let's start by the data collection and processing. So we have developed a Python crawler to collect Twitter data by sending a GET request to the Twitter API, and the requests contain keywords related to cardiovascular diseases located in the United States of America, and of course, English tweets in specific periods from 2016 to 2019. So we have collected 11,100 tweets. And now, concerning the data processing, which consists of the cleaning of the tweets by removing links, user references, hashtags, punctuation, and emoticons, and then eliminating retweets to avoid redundancy, and finally normalizing the data by transforming the tweets into lowercase. And these operations was done by Apache Spark in order to ensure faster preprocessing, and we have saved the clean data in a CSV file, which counts 10,059 cleaned tweets. Now let's move on to the classification of personal and non-personal tweets. Here. So a personal tweet is a tweet that transmits the author's private state. A private state can be a feeling, an evaluation, an emotion, a judgment, an impression, and so forth. And a non-personal tweet is a tweet that states an objective fact, and so the classification is based on the degree of subjectivity of the tweet's text. And since the classification is supervised machine learning technique, we have prepared a labeled dataset in order to train our algorithm. So first, I will introduce briefly the MPQA, which is a corpus that contains 8,000 words that's with words with its degree of subjectivity. So if the type of the word, as you can see here, is a weak subjectivity, it is an objective word. And if it's a strongly subjective, it is a subjective word. So we have automatically labeled the tweet using linguistic rules. And each tweet having at least two subjective words automatically, two subjective word is automatically labeled as subjective tweet, which means it's a personal tweet, and otherwise it is a non-personal tweet. So a problem with text modeling is that it is messy, and techniques such as machine learning require a well-defined fixed length inputs and outputs and cannot work directly with plain text. So text must be converted into numbers and more precisely into vectors of numbers. So this is called feature extraction or feature coding. Feature coding. So in this step, the plain text data will be transformed into characteristic vectors, and new characteristics will be created using the existing dataset. So in our case, we implemented two methods of extracting characteristics, TF-IDF and the count vectors. And for the classification, we have used SVM multinomial naive Bayes and random forest, and finally logistic regression. So now let's move on to the classification of tweets based on their polarity. First, I will introduce briefly the SanticNet, which is a corpus that provides the polarity associated with 50,000 natural language concepts. So we have automatically labeled the tweets using linguistic rules, and each tweet having at least 3 negative words is labeled as a negative tweet. Otherwise, it is a positive tweet. So we implemented two methods for extracting characteristics, the TF-IDF and the count vectors. And for the classification task, we have used the SVM, multinomial naive Bayes, random forest, logistic regression. So for our problematic, we are interested in negative personal tweets about cardiovascular diseases that can be considered as an indicator that the user is at risk of having cardiovascular disease. So the results for classifying tweets into personal and non-personal tweets using TF-IDF as a method of extracting characteristics are better when applying the 80% distribution of training and the accuracy in training, and the accuracy of the test data is 90% for logistic regression and 89% for the SVM. So here we have obtained the same result when using the count vector as a method for feature extraction, and we have an accuracy of 90% for logistic regression and 89% for SVM. The results here for classifying personal tweets into negative and positive using TF-IDF as a method for feature extraction gives an accuracy of 81% for random forests that had the best performance here. And the results for of the classification using count vectors as a method for feature extraction gives an accuracy of 89 for both SVM and logistic regression. So we can say that the count vector as a method for feature extraction combined with SVM or logistic regression gives better performance. So we aim in the future to improve our work by improving the performance of our model by adding more data and more learning data. So a recommendation system can be implemented to provide users at cardiovascular cardiovascular risk with suggested pages and links to follow a healthy lifestyle. And to conclude, I can say that our approach doesn't predict the heart disease for Twitter users. It is rather a preliminary approach that can be further developed to classify the health status of Twitter users if they are at risk of having heart disease. And I can say also that our study shows that the monitoring of public sentiments on Twitter, combined with contextual knowledge about the disease, can detect health and disease tweets and potentially be used as a valuable proxy for health-related indicators. And furthermore, social media analysis might be used to identify user or community with increased health risk over a specific spatial and temporal range. So that's all for my presentation. Thank you for your attention. And is there any questions?
Thank you so much for being with us and giving the great presentation. We are like half an hour after the time, so I'm things just like congratulating you for really good research and hoping that you will stay with us for also the next year. And the next year we will be, it will be possible for us to meet in reality. Yes. Thanks to all participants that are coming to the session for so many years, and I hope all will come to the session next year. I see Audrus is there, so I'm passing voice to the studio. Audrus.
Okay, so Martin, thank you very much. Thank you very much for participants. Thank you very much, Martin, for cheering. Look, Martin, this is the package of waiting here in our studio.
Super.
Okay, I'm joking. You do not need to arrive to take them. We will send you by mail, okay?
Thank you so much.
And Martin, please think about the best paper award or kind of proposal from your section. The best paper award ceremony will be on Saturday at 3 p.m. So please think about it and please suggest the most suitable article and presentation.
Sure, sure. We communicate in the evening.
Great. Okay.
Of course, great.
Okay. So thank you very much. Thank you very much, and see you tomorrow.
Thank you so much. Stay with us. See you tomorrow and also the next years. Bye bye.
Okay.
Thanks for
Bye.
all.
Thank you for all.